Good afternoon, everyone. Am I audible? Can anybody respond?
Yes, you are audible.
Yeah, thank you, madam. So I welcome all the participants to day 7 of our program. That is online and ICT faculty development program on optimization technique, theory, practice, and emerging application. And today we have two sessions. So in the first session, we'll discuss about remaining MCDM methods and implementation of MCDM methods. So in my last lecture regarding this MCDM methods, we have discussed a lot of methods like we have discussed weighted sum method WSM, and we have discussed about WPM, which is an extension of WSM method. Then we have seen the popular method that is called as Promethi, and I told you how to extend the Promethi by introducing a new kind of normalization rather than only considering 0 or 1. Then we have discussed another MCTM method, that is Beaker, which is this Beaker word is a Serbian term. Then we proceed to another method that is called as Topsys. That is called as a technique for order preference by similarity to ideal solution. And last we have discussed the sixth method, and the last method is based upon graph theory matrix approach, right? In which we consider metrics into consideration. But the slide we have little bit changed the matrix, the way we are computing a matrix determinant. It is slightly different, but more or less the concept is related to determinant of matrix. So these six methods we have discussed. So in the first session, we will see the remaining two methods. One method is called as Mura, which is also a very famous method. It stands for multi-objective optimization using ratio analysis. Okay, we have also discussed, if you remember, we have seen in the last lecture regarding leaving flow and coming flow, right? Based upon that, we are calculating one particular value. So similarly, here we are doing the ratio analysis. So first we'll start with the Mura method. Then we'll see one of the very popular method in comparison to all the method, that is called analytical hierarchy process, also called as AHP. So I'll give you two different, you can say, example or case study related to AHP. One case study will solve through hands-on calculation. Another case study which we used for all these MCDM methods. That
Hello.
case study we'll see for implementation perspective. Yeah, Salim
Hello.
sir, please. Yeah, please.
Sir, thank you very much for allowing me, and very good day to you.
Yeah,
Sir,
yeah,
we actually learned about multi-criteria decision making earlier day, right, sir? I guess
yeah.
day before.
We have not,
Okay.
yeah, we have not discussed these two methods. We have discussed only these six methods. We have not discussed this particular methods.
Okay. So today, actually, we are going to learn about Mora and ASP, right, sir?
Exactly, and their implementation.
Oh, okay, sir. Thank you very much, sir. Please carry on.
Yeah, yeah. So AHP part, as I told you, we will go for two different study. One study will do hands-on calculation. Okay. Another is the implementation in the MATLAB, right? So that you can understand how AHP algorithm makes a decision. In our today's second session, we have already discussed about the genetic algorithm, but we will see one of the case study of the genetic algorithm by Dr. Lab Kumar from NIT Kurukshetra. So he'll discuss about one particular case study where you can apply genetic algorithm. So this is the agenda for today's two talks or two different sessions. Yeah, this is the topics we have which we have discussed, except the red colored one, like multi-objective optimization using ratio analysis. We have not discussed. Analytical hierarchy process also we have not discussed. Rest of the methods we have already discussed. And just to give a brief about others, those who missed my first session related to this MCDM methods, I just want to summarize what we are actually doing in MCDM methods. So I told in the very first lecture, means in MCDM lecture, that multi-criteria decision making, as the name suggests, you have a set of criteria. Like we are visiting to many places to purchase a shopping mall, or you can say local shops to purchase refrigerator, purchase air condition, purchase a laptop, desktop, or online source also, or online shopping websites also. We are visiting to purchase a particular item. So we have a set of criteria, right? Like one of the criteria which is very common for all type of uh, purchase is called as cost. Okay. Another criteria may be what is the warranty of the product. Another criteria may be what is the power consumption of that particular device. Like that, we have set of criteria, right? The criteria may be a qualitative criteria or it may be a quantitative criteria, right? So So, given a set of criteria, you have to finally decide one of the item. For example, you have a set of alternatives, okay, and you have to choose a particular alternative which satisfy all the criteria, right? So that is called as our multi-criteria decision-making problem, which is of two type. One is called as a multi-objective decision making, that is called as MODM, where you have set of objective, right? Like minimizing cost is an objective, maximizing a profit is objective, minimizing the time is an objective. So based on several objective, you are taking a decision. Okay, like you can say if I have three criteria, three objective, one is objective one, another is objective two, another is objective three, then you can say I can give objective one the weight 0.33, objective 2 the weight 0.33, objective 3 the weight is 0.33. So you are equally giving weight to each and every objective, right? Somebody will say that no, objective 1 is very important to me. Okay, objective 1 is very important to me, so I'll give objective 1 as zero point 0.5, and objective 2 is next important to me, I'll give 0.3, and objective 3 is 0.2. So more or less, you can see the sum is equal to 1. Okay, this is also sum is equal to 1. So that type of problem is called as objective decision making. Here we have several attributes. Sometimes also we can ignore one or two attributes, which is not really important for our case, right? So although we are solving the problems using multi-attribute decision making, but as multi-attribute decision making is very popular, so sometimes we refer these methods as MCDM method. But actually, they are multi-attribute decision making methods. They are not multi these criteria methods, right? So in that way, it is different because you have seen multi-objective, multi-attribute both are different. But the term multi-attribute actually dominates the multi-criteria. That's why we use multi-criteria word in order to describe these methods. And what kind of problems you can solve in MODM? I told you in earlier lecture, that is design problems you can use MODM. Selection method you can use MLDM. Suppose you have five choices, like you see for a particular student in a university, he got five offers, five job offer one, job offer two, job offer three, job offer four, job offer five. So out of these job offers, the student has to choose only one job offer. He cannot take a two job offer at the same time, right? So he has to choose one of the job offer. So what are the maybe the criteria? Can anybody say what are the criteria to select a particular job out of these five jobs? What may be the criteria the student should consider in order to select one job out of these five jobs? Can anybody guess what are the criteria? Any answer? What are the criteria we need to consider? Can anybody guess? One of the criteria you may say here that we need to consider, that is called as the location. Okay, the student will see what is the location of job 1, job 2, job 3. Another is the package, right? Package. Another may be the reputation of the multinational company, right? Like that, we have a set of criteria, right? So by considering these criteria, what the student has to do, a student has to choose one alternative. So these are called as your alternatives, and these are called as your criteria. So in MADM, what we are doing, we are making a selection of a particular job out of 5 different jobs, right? And if you look into the solution perspective, here the solution is finite, right? Because you know all the 5 jobs and their location, package, reputation, and other parameters you know. But when you go for MODM problem, it is infinite. We do not have any idea how many solutions are there. Similarly, if you see with respect to discrete variable and continuous variable, MADM takes discrete values. These values, whatever we have as a performance values, these called as discrete value. They are not continuous values. But when you go for MODM problem, you will see a continuous value. And this slide also we have discussed in the previous lecture. So these are the 4 things you have to identify for each and every MADM problem. First one is called a set of alternatives. Like here we found the alternatives are J1, J2, J3, J4, J5. 5 different alternatives. And we have a set of attributes. What are the attributes we have considered? We consider location is an attribute, package is another attribute, reputation is another attribute. You can consider bond period is another attribute. Like that, we have a set of attribute to select one of the job out of these 5 different jobs. Right? Now, what is the third one? Third one is weight. Each and every attribute or criteria is having a weight value. A student may say that package is more important me, so I am taking 0.4 is the weight value. Although assignment of this weight value to the attribute is based upon experience. Okay, whether to give 0.4 to package or location, that is based upon past experience. If the student has no past experience, some decision maker can suggest that student. One decision maker can suggest the student to choose this particular weight value for each and every criteria, right? Let's say location is next to package, reputation is also important, so you can consider 0.2, rest are 0.0005, something like that you can say, right? But some of these weights is equal to 1, otherwise you have to normalize it in order to make it 1. And the performance measure values for each and every alternative with respect to attribute is an important component. Because by looking into these performance measure values, you have to guess, right? Or you have to choose, you have to make a decision in order to select one particular alternative out of all alternatives. Again, we have seen also in the last lecture, attribute and criteria, they may be of 2 types. It may be beneficial attribute or it may be non-beneficial attribute. Right? Attribute may be beneficial attribute or it may be non-beneficial attribute. Beneficial means higher value is better. Non-beneficial means lower value is better. Okay. So these are the background for any MADM problem or MADM method. So once you know these things, you can identify this in your particular research problem. You can apply MADM problem, right? Like in my respective area, that is I'm doing work in the field of cloud computing. So we have different cloud services. Okay. Like Amazon is providing cloud services, IBM is providing cloud services, Microsoft is providing cloud services, Google is providing cloud services, right? So for a customer, right, which cloud he has to choose for his individual purpose or business purpose, that is also a example of your MADM problem. That but each and every you can say user has four alternatives. Let's say out of these four alternatives, you have to choose one of the alternative. Again, you consider various factors like cost is a factor. You consider uh, reliability is a factor. You consider availability is a factor. Failure is a factor. Based upon that, you have to choose one of the cloud service provider. Basically, we are taking the role of a chief technical officer. There is a CTO in each and every company. CTO is responsible to take technical decision. So if CTO wants to take one cloud service provider, he has to go through several attributes. Based upon this attribute, the CTO is going to take a decision for his company, right? Okay, so with this background, let us start the first algorithm, that is Mura. Then we'll go for AHP. We'll discuss more about AHP, less about Mura, because Mura algorithm more or less similar to one of the algorithm which we have seen in the previous lecture, right? So these two we are going to discuss, Mura followed by AHP. So let us solve the Mura method, right? So suppose in the Mura method, you are given with uh, 7 different alternatives. Okay, so I'm writing alternative. ALT stands for alternative 1, alternative 2, 3, 4, 5, 6, 7. 7 different alternatives. Assume that there are 4 different attributes we have. One is called as attribute 1, we have considered in the last class about toughness index, and we have taken another attribute as yield strength, and we have considered another attribute as density, and T, that is called as thermal, right? So these we have considered in my last lecture, right? Same example I am telling you to explain the Mura. Suppose the attribute values for the toughness index, okay, that we have taken in the last problem. Okay, we consider this one is 75.5 if you remember. Okay, any value you can take which is given to you. So when you take a real case study, you will get the exact value of these uh, different attributes, right? Which will help you to take a correct decision. But here we are taking the arbitrary values. So I'm copying the same value. One is 187, 179, 239, and 275. So the first step of Mura algorithm is to calculate the denominator. Okay, denominator D. Okay, so in order to find the denominator, what you have to do, you have to take square of the attribute value. Like these are the attribute values, that is 75.5 for alternative 1. Alternative 2, it is 95, 770, 187, 179, 239, and 273. So you have to determine square of each and every value. So if you calculate the square of 75.5, how much you will get? Can anybody answer? 75.5 square, which will give you the value, that is the square of value. When you sum these values and take root over, you will get the denominator D. Can anybody tell me 75.5 square, how much you will get? Calculate it in your calculator.
Hello.
Yeah, Samim sir.
Sir, it will be, I guess it will be something like 4925. Sorry, 4927.5.
4927.5.
I guess so. I'm not sure. I'm not calculating it with the calculator.
Yeah. So Nilesh sir mentioned it is 5700. Yes, I am also calculating through calculator. So you will get the value as 5700 is right, 5700.25. Similarly, if you calculate 95 square, so you can use your smartphone calculator. 9025 you will get. Similarly, 770 multiplied by 770 or square, you can use function 592900, you will get is a big value. 187 multiplied by 187, you will get 34969. Similarly, 179 multiplied by 179, you will get 32041. And 239 multiplied by 239, you will get 57121. And 273 multiplied by 273, you will get 74529. So this is nothing but your TI square, right? So if you sum these values, sum it like 5700.25 up to 74529. If you sum it, check how much you are going to get. 5700.25 plus 9025. Can anybody calculate and help me? I am also calculating, so we can cross check our result. So just you add these values in your calculator and tell me what is the sum value you are going to get. Okay, I have calculated the sum. If you have calculated, you can say, or you can write in the chat box, sum of the TI square values. So if I am correct, the sum value I am going to get is the sum of TI square is nothing but I am getting here 806,285.25, right? So in order to calculate the denominator d, what you have to do, d is equal to root over of summation of TI square. So you will get the value is root over of 806285.25, and its root over, it will give you 897.9339. Okay, so this is the first calculation related to TI, our first criteria. Yeah, Nilesh sir also got the same value. Just you find the square root of that particular value, you will get the value as 897.9339. Okay, if you go for the second one, it is 420. The values are 420, 91, 1365, 1120, 875, 1190, and 200. Right? These are the performance values of yield strength with respect to all the alternatives. Right? So what we have to do? We have to find ys whole square. Ys whole square means, again you have to calculate here the square. 420 multiplied by 420, you will get 176,400. Okay, then 91 multiplied by 91, you will get 8281. 1365 multiplied by 1365, you will get 1863225. Similarly, 1120 multiplied by 1120, you will get 1254400. 875 multiplied by 875, 765625. 1190 multiplied by 1190, So you will get 1416100. 200 multiplied by 200, you know it is 40,000. So now you can calculate sum of ys square. That is 176,400 plus 8281 plus 186,3225 plus 1254400 plus 765,625 plus 1416100 plus 40,000. So if I'm correct, I am getting here 5524031. 031. Okay. So if I find the denominator d in this case, it is root over of summation of ys square is equal to root over of 5524031. Okay. If you find the root over, of 5524031, you will get 2350.3257. This is the d value. And the reason of calculating this denominator is that we are going to divide this value with each and every performance value of that particular criteria. Like we got the denominator value here is 897. So we have to divide each and every value by 897.9339. Similarly, we have to divide all these ys values by 2350.3257. That is the reason why we calculate denominator. But if you go for the previous methods like WSN or you can say WPM, there you are doing x, you can say x divided by x max, right? For beneficial attribute in order to scale it, and x mean divided by x for non-beneficial attribute, right? So you can say in order to normalize, different MCDM methods uses different process, right? One process may be dividing with the highest value in the case of beneficial attribute and lowest value in the numerator part and performance value in the denominator part, or on the other hand, you can take the square, sum its square and find the square root. That will give you the denominator value. Then you can divide the denominator with each and every performance value. Okay, like that you have to process. Like this method we have already done, right? For TI, similarly do it for YS, that is yield strength. So yield strength case, I hope we got 2350 is the denominator, 2350 point something. Yes, you can see here we got the value is 2350.3257. Similarly, you have to take for D, right? D case you will get 2.8 square, 2.68 square, 7.9 square, 7.9 square, 4.43 square, 8.51 square, 8.53 square. This will give you the D value, D square value. Okay, and once you get the sum, okay, sum of D square, then take its root over. Okay, in order to find D, you have to take root over of sum of D square. That will give you denominator of this particular attribute against all the alternatives. Okay, then what we will do again, I am going to calculate T square. T square is nothing but 21.4 square, 22.1 square, and 16.9 square, 14.4 square, 9.4 square, 11.5 square, and 19.9 square. Okay, if I calculate the sum of T square, It is nothing but sum of all these squares. Then in order to find the denominator d, you have to do root over of sum of t square. That will give you the denominator of the respective term. Okay. So if you carry out this process, you will get these are the d values. D values for Ti, D values for Ys, D value for density, and D value for T. This is the first step of our Mura algorithm. In fact, if you see, the first step of Mura algorithm is similar to the Topsis algorithm, which I told you in the previous lecture. Topsis stands for your technique for auto preference by similarity to ideal solution, right? So the Topsis method also do this calculation, but after this, the step of Topsis and the steps of Mura is completely different. Okay, now in order to normalize the weight values, you can see the weight values are not normalized. Some of these weight values are not equal to 1. In fact, 6 plus 2 is 8, 8 plus 3 is 11, plus 1 is 12. So in order to normalize these weight values, what you will do? You will calculate sum of the weight and 6 divided by 12. Then you have to do 6 divided by 12. For the second one, it is 2 divided by 12. Then 3 divided by 12. 1 divided by 12. You will get normalized weight value. Okay. Denominator value will help you to normalize the performance values, like 75.5, 95, 770. These are the performance value. I have divided these performance values by 897.9339. So now all these values are normalized to 0 to 1. And the second step is you have to calculate sum of the weight and divide that with the respective weight. Okay, then you will see your weight value is normalized. Right? Normalization methods may be different. You can also find a new normalization method and can apply here. Like I mentioned about in the previous class related to min-max normalization. In the data mining subject, you will find min-max normalization. Another normalization you will find that is called as zero min or zero score normalization. Okay. Third normalization is called as decimal scaling normalization. Right. Okay. You can see also if you go to literature, you will find one of my article related to the normalization, in which you will see we have advanced this normalization technique by stating their pros and cons. Right. So there are other normalizations we have used. One is called as the Reddick scaling normalization. Reddick scaling. It is developed by me as a part of my PhD work. Okay, and also we have proposed another normalization based upon 68, 97, and 99 rule. Okay, there is a thumb rule is there, which we called as 68, 97, and 99 rule. Okay, sorry, this is 95, not 97. 95 and 99 rule. With that also, you can normalize this data. Only you have to show that your decision is better than the decision made by these different algorithms. Okay. Now, once you have normalized this one, this look like this one, right? All the values you see, these values are in the scale of 0 to 1. So they are properly normalized. Then what you can do in order to calculate these values, okay, in order to find the, you can say weight value, you can say, or you can say final value for each and every alternative, you have to multiply the weight with the normalized weight with the normalized performance value. Normalized weight multiplied by normalized performance value. Okay. So for example, if you go for alternative 1, what we'll do? We'll multiply 0.5 with 0.0841. So 0.5 is the normalized weight multiplied by 0.0841. Similarly, if you go for the second attribute, then it is 0.167 multiplied by 0.1787. Then 0.25 multiplied by 0.1604. Then 0.083 multiplied by 0.4720. Okay, like that for alternative 2, what you will do? You will take the same weight, multiply with this performance value, 0.167 multiplied by 0.0387, 0.25 multiplied by 0.1535, 0.083 multiplied by 0.4874. Okay, yes, this calculation. After this calculation, you will also see the values are in the range of 0 to 1. But what is the difference between the previous value? In the previous value, the corresponding weight, these weight values, you have not multiplied. Okay, if you go back to this slide, and see here, we have not multiplied the corresponding weight value, because weight value has an importance, right? Which criteria you are giving more importance, which criteria you are giving less importance, that will be taken care by looking into your criteria weight. So that's why we multiply the criteria weight with the normalized performance value, normalized weight with normalized performance value in order to get this value. Now what you will do? Now we need to calculate one index. Okay, index. Index means y. Okay, we represent index by y, or you can say combined values. So you have calculated, multiplied this thing. Now there is no role of this one, this weight value, because weight value we have already multiplied in the previous slide. You can see here, weight value is already multiplied, so there is no need of weight value. So now we need to calculate the index. Okay, so how to calculate this index? Index is nothing but, you will see which criteria is beneficial criteria here. You know, the beneficial criteria is dy and ys. Non-beneficial criteria is d and t. So in order to calculate index, you will take 0.0421 plus 0.0298. Then these are beneficial criteria. So beneficial criteria, always you have to add. Non-beneficial criteria you have to subtract. So there are two non-beneficial criteria. So I can do minus of 0.01 minus of 0.092. That will give you the index y of alternative 1. Similarly, calculate for 2. Can anybody calculate for 2 and tell me? I am giving you 1-2 minute time. Calculate for 2 and tell me what is the value you are going to get. You have to sum the beneficial attribute values and you have to subtract non-beneficial attribute value. What is the value you will get for 2? Quick, calculate it. So it is nothing but 0.0529 plus 0.0065 minus 0.0384 minus 0.0405. Okay, what we are doing? First two are the beneficial criteria, that's why we are adding. Second two are non-beneficial criteria, that's why we are subtracting. Okay, so if you calculate this sum value, I think if you calculate, let me calculate our first two, then I'll show you the answer. 0.0421 plus 0.0298 minus 0.0401 minus 0.0392. The first one you will get minus 0.0074. Okay. Second one minus 0.29, sorry, 0.0529 plus 0.0065 minus 0.0384 minus 0.0405. So you get minus 0.0195. Like that, you calculate index y for alternative 3, 4, 5, 6, 7. Once you get this alternative, what you have to do? You have to find the maximum y value out of all the 7 values. So if you see here, the maximum value you are getting in which case? Maximum value you are getting in this particular case, that is 0.3817. So the rank of that particular alternative is 1. So which alternative is 1? It is suggesting, this Mura method suggesting to choose alternative 3 is the best value. Similarly, find the next highest value. The next highest value 0.0 positive, negative will not come. Okay, 04, 08, 07. So 08 will come. So that is your second best alternative. So second best alternative is 5. So if you order of the rank, order the alternatives. If you order the alternatives based on rank, so first alternative will come A3. Second alternative will come A5. Next best is this one. So I'll write A6. Next best is 4. So I'll write A4. The next best is A7. Okay. Then which one is better in these two cases? The less negative value is better, right? It's just opposite of our positive scale, right? So A1, then A2. So these are the alternatives order we found from the Mura algorithm. Okay. So in this way, you can solve the problem of Mura. So let me repeat the steps. First, we have calculated denominator. Denominator is D. How to calculate denominator of a particular attribute? You have to find square of the performance values. Then you have to calculate sum. Then you have to calculate square root. Square root will give you the denominator D. Right? What is the second step? The second step is we have to, after finding denominator D, we have to find the weight normalization. Sum of the weights you can find and divide with the respective weight to get the normalized weight value. Right? Now coming to the third one. What you will do by taking this denominator D, there are multiple denominator for each and every criteria. You have one denominator. So divide that denominator. Okay, use each and every denominator to divide it from the performance value. So performance values of the first criteria is divided by its respective denominator. Right? Then what happened? You have done the normalized weight multiplied by normalized performance value. Okay. After that, you have calculated the index value y. Okay. Index y is calculated by considering if it is a beneficial attribute, make it plus. If it is a non-beneficial attribute, make it minus. Right? And once you get the index value, choose the highest index value as your best alternative. Okay, you have to choose highest index value as your best alternative. Okay, is there any question related to Mura before moving to the next algorithm? Any question related to Mura?
Sir, I have two questions.
Yeah, Arun sir, please.
Sir, actually, you are assigning weight now, sir.
Yes.
In what basis we are assigning the weight for the parameters, sir?
Weight is, as I told you, weight is based upon the past experience. Only the decision maker, those who are usually take decision, they can specify what kind of weight you can put for each and every criteria. But for this calculation, I have arbitrarily taken as 6231 or something like that. I go back.
Yes, yes, sir. Yes, sir.
Yeah. But only
Total is coming
experience
12.
holder. Yeah, 6231 I have taken. So sum is coming as 12. But only the decision maker, the company, the CTOs are there. They are the right people to say what kind of weight value you have to set for each and every alternative. And what is your second question, sir? Arun sir?
Next, your influential parameters, sir.
Which
Tensile strength
parameter,
and the
sir?
yield strength. You said two parameters,
Yes.
tensile
Yeah,
yield and
yeah,
the influential parameters. Others are non-influential parameters now, sir.
yeah.
So how we are telling these the two parameters are influential and another are non-influential?
You forget about these things, sir. For example, if you go for purchasing, as I said, purchasing an air condition, right? So you are looking into star, right? Whether it is 5 star or 3 star. So if we increase the star, then the power consumption is less, right? So it is a beneficial criteria, right? Cost case.
Yes, sir.
Cost case, we know that less cost is better, but we should not compromise the quality. So cost is a non-beneficial criteria. Like that, you have to decide which one is your beneficial criteria, which one is non-beneficial criteria, with respect to your research problem.
Yes, sir. While we are going with new research, we couldn't able to find out which is the beneficial now, sir. If we are proceeding with the first, if it is a new material,
Yes.
so if it is tensile strength of new material, we couldn't able to find out which is the beneficial from the mechanical parameters like tensile and yield now, sir.
You have to identify, sir. Without that, calculating MCTM problem is not possible because you are not only
Yes, sir. Yes. For
considering.
known thing only we can able to do it.
Yeah, but because you are not dealing with only one material, you have several
Yes, sir.
materials.
Yes,
You have
yes.
several materials. Each and every alternative is a material. Out of that, you have to choose one material. So you should know which one is better for them, which one is not better for them.
So it seems it is also similar to GA only, no, sir. Ranking
GA
and then we are
GA case,
rank.
each and every population is a valid one, sir. But here we are not worried about that. We have to choose only one out of a set of alternative. GA case, we want everyone should be, suppose 7 solutions are there. After 50 iteration, you will see all
Yes,
values
sir.
are close to the global solution. But here you will not
Yes.
find that one. The 7 alternatives are unique. They will never converge at a single point.
Fine, sir. Fine. Thank you.
Yeah. Any other question, anyone? Okay, if there is no question, I'll proceed to the next very important algorithm that is called as analytical hierarchy process. So this analytical hierarchy process was developed by Thomson L. Sathi in the year of 1970. It is not a new algorithm, but still, if you see, especially in the field of cloud computing, recently people have used the ASP algorithm. In the last couple of years only, they have used ASP analytical network process they have used. So why this algorithm is popular in comparison to other methods which we have discussed till now? You can see here, it is a structured way of organizing and analyzing the complex decisions. Sometimes we are taking a decision based upon the component, but a component has several subcomponents as well, right? Like here I have taken toughness index and yield distance, something like that, right? If that is a component, again under that component you have various subcomponents. So that also need to be considered in order to make a decision. That's why in order to solve a problem where you have to take a complex decision, your decision is very, very complex because the way they have organized, the way they are related to each other, AHP is the better MCDM method to apply in that situation. AHP is also used for taking complex decision under certainty. So there is two things. One is certainty, another is uncertainty. Uncertainty means suppose you have assumed that you will reach to your destination at 5 p.m. But there is a traffic jam or there is a accident happens. So due to that, your thing is delayed. Right? Instead of 5 p.m., you are reaching at 6 p.m. But here, whatever we consider that is called as certainty. That is not uncertainty. Again, many MCDM methods deals with uncertainty, right? Because all the problems are not, whatever values you are taking, that they may not be certain, right? Many complex environments, if you see, the values are uncertain, right? So here, the subjective judgment is quantified in a logical manner. Again, the judgment is of two types. One is called as subjective, another is called as objective. Like I'll ask you whether to take a particular decision or not. So your answer may be yes or no, right? But if I ask you what is the cost of a particular system, then it is comes in the price, which is not subjective, it is objective. So sometimes we have to consider the subjective as well as objective, and we have to use both in order to make a decision. And ideas, feelings, emotions affecting the decisions are quantified on a numerical scale or prioritizing the decision alternatives. Finally, each and everything need to be modeled in a numerical scale. The scale may be 1 to 5, it may be 1 to 10, it may be any value, any real values you can say in order to make a particular decision. And human judgment is used in the performing evaluation. Human judgment means sometimes you have a set of a decision maker, like exit poll, right? Before the counting of votes, generally news channels they show the exit poll. So what actually they are doing? There is a box they are placing outside each and every voting center, right? Once a person has voted, cast his or her vote, they are giving a blank seat or the same seat. Nowadays EVM machines are there, but they are giving a seat and they are asking whatever you have selected inside the voting center, you can also select the same thing and place in this particular box. Okay, place the seat or place a kind of cheat inside that particular voting blocks. So what they are doing, let's say there are 10,000 voters in a particular place. So they have collected 1,000. They are not collecting for each and everyone because many times one person is not going to express his opinion outside, right? Or he or she is not liking to express the opinion in the form of a cheat. So out of 1,000, they count that how many votes are going to team A, team B, team C, right? So there also what we are doing some kind of judgment. Before the actual judgment, we are doing the another kind of judgment. Sometimes also it is having error also, right? Sometimes the 1,000 samples what you have collected out of 10,000 samples, okay, maybe they have casted to team A and they are given to team B in your case. Or sometimes you have collected the 1,000 samples which is related to, let's say, first hour or second hour or middle hour, which may be different from the actual judgment. And AHP converts these evaluation to numerical values that can be processed and compared. So for this, let us go through a simple example. Okay, let us do a hands-on calculation. Through that, I'll tell you how actually AHP works. So you can consider this is a case study. Assume that there is a student, right? Let's say the student name is Ram. The student has applied to 3 different universities. Let's say he applied to university. I'm writing UNIB, University A, which is situated at United States of America. Another is University B, situated in Singapore, and University C, which is situated at Japan. Okay, the same student has applied to 3 different universities for admission. Okay, now the student has 2 different criteria. Okay, the student has 2 different criteria. The student is looking into the reputation of this academic institution. Okay, reputation of this academic institution, which we call as AR, academic institute reputation. Also, the student is looking into the location of these universities, which we represent as AR. Okay, these are different criteria. You may consider multiple criteria also, but as a simplicity of this illustration, I am considering academic reputation and academic location. So again, academic location, reputation, academic location is not 0.5, 0.5. The weight is not same. So as a student, he feels that academic reputation of a particular university is 5 times as important as location. So reputation to location, the difference is 5 times. If you give the reputation as 5, then location is 1. So for him, if you compare these 2 criteria is differ from each other with respect to 5 times, right? Means one value, if you give one value a particular attribute, the next one is 5 times, right? Now what you have to do, there is some relative weightage of various universities with respect to these 2 criteria are given to you, right? For example, with respect to location, if you go for with respect to location, I'm writing AL. So it is given that let's say this is your University A, University B, University C. Here also I'm taking University A, University B, University C. Okay, so I can say university, these obviously the same university you will get the value as 1. Let's say one university to another university, his importance is 2 here. In comparison to these 2 universities, the importance value is 5 here. So this matrix is called as your relative matrix, relative weightage of various universities. So once you know about this column, the reverse one, like if you calculate A to, you can say B to A is 2. Right? If I go row, then column. B to A is 2. Then if you calculate A to B, it is 1 by 2. Similarly, C to A is 5 means A to C is 1 by 5. Similarly, if I go for this one, like B to C and C to B, you have already taken. C to B is 1 by 2. C to B is 1 by C to B. C to B is 1, right? C to B. C to B is not defined till now, right? Okay. So in this way, if you calculate B to C, or you can calculate now again C to B, then you can calculate B to C. This is also not defined. So you will get this value as 1 by 2 and this value is 1 by 2. Sorry, this value is not 1 by 2. Okay, this value is 1 by 2 and this one is 2. So basically this particular matrix is given to you, right? But you can see once you know one value, one side of the value, you can guess the next side of that particular value. Similarly, if you can take AR is with respect to the reputation. Let's say with respect to reputation, if you compare these 3 universities with them, then you will get the value is 1, 2, 3. That means University 3 is more important than University B and University A. Similarly, if you calculate the alternate value, it will get 1 by 2. This is 1 by 3, and these values are 1, and this value is, let's say, 3 by 2, and this value is 2 by 3. Okay, basically this data up to this, it is given to you, right? Now what you have to do in order to solve this problem, right? I already mentioned, the student one mentioned to you that reputation is more important. In fact, it is 5 times than the location. And also it is given that the weighted matrix, right, that you call as a relative weightage matrix is given to you. So in order to solve this matrix, you have to go for normalized. The matrix name is called as normalized location. This is called as academic location. This matrix you have to normalize. That's why I'm giving the name as NL. Okay. In order to calculate the normalized matrix, what you have to do? First, you have to calculate column total. So column total means here you can see 1 plus 2 plus 5. So it is 8. It is nothing but 3 and 1 plus 1 by 2. So it is 3.5. It is 1 by 2 is 0.5, so 1.5, and 1 by 5 means 0.2, so it is 1.7. So I have calculated the column total. After finding the column total, you can calculate the normalized location matrix. How to calculate? You will divide each and every value with respect to their column total. So I'll write 1 by 8 here. It is 2 by 8. It is 5 by 8. Similarly, I will do here 1 by 2 divided by 3.5. Similarly, 1 divided by 3.5 and 2 divided by 3.5. Here 1 by 5 divided by the column total is 1.7. 1 by 2 divided by 1.7. 1 divided by 1.7. Is it clear how we have normalized? How we are getting this particular value? Can anybody respond? Is it clear? Any question till now? Okay. So if there is no question, we have calculated the normalized academic location matrix, you can say. NL. We represent as NL, or you can represent as NAL. So we have calculated the column total, and we have divided the respective value of AL matrix. So we got the value as NL matrix. Now you have to calculate the row average. Okay, row average is nothing but you have to calculate 1 by 8 plus 1 by 2 divided by 3.5, 1.5 divided by 1.7. So I will take the average of these particular values. So let me calculate. So if you calculate here 1 divided by 8, that is 0.125 plus this is 0.5 divided by 3.5. So you are getting 0.142 plus the last one is 1 divided by 5.2 divided by 1.7. So that is 0.11764. Okay. So if I sum it, then how much I will get here? I will get the value as 0. Okay. If you sum it, you will get, I think, 0.38464. And if you calculate the average divided by 3, you will get the value as, just a minute, you will get the value as 0.129. Similarly, if I do 2 divided by 8, it is, it is 0.25 plus 1 divided by 3.5 you will get 0.2857 plus 0.5 divided by 1.7. So you'll get 0.29411. So if I sum these values, I will get the value as 0.8298 divided by 3. So I'll get the value as 0.2766. Okay, or 277 you can say if you want to take 3 decimal digit. Now here if you take 5 divided by 8, it is 0.625 plus 2 divided by 3.5, you'll get 0.571 plus 1 divided by 1.7, you will get 0.58823. Okay, if you sum these values, you will get the value as 1.78423 divided by 3. You will get, you divide by 3, you will get the value as 0.594. So what we did, we have normalized this particular matrix and we have calculated the row average value. Now this is one criteria, AL is one criteria. Let us proceed to the another criteria. That criteria is AR, that is called as academic reputation. There also you find the column sum. Okay, column sum is, if you calculate here, 1, this 1 by 2 is 0.5, 1.5, and this 1 by 3, 1 divided by 3, you will get 0.33. Okay, so it is 1.83, right? This value we are getting 1.83. Similarly, 2 plus 1, 3. 3 plus 2 divided by 3. So I think you will get 3.66. Similarly, in this case, it is 3. 3 plus 1 is 4. 4 at 1.5. That is 5.5. So if I go for normalized reputation, so NR, a normalized reputation is nothing but 1 divided by 1.83, 0.5 divided by 0.5 divided by 1.83, then 0.33 divided by 1.83, 2 divided by 3.66, 1 divided by 3.66, 2 by 3 means it is 0.66, right? 0.66 divided by 3.66, 3 divided by 5.5, 1.5 divided by 5.5, 1 divided by 5.5. Okay, so now you have calculated the normalized reputation. After finding normalized reputation, what you will do? You have to calculate the row average. Okay, so 1 divided by 1.83, this is 0. You have to calculate this one, right? So 1 divided by 1.83, it is 0.54644 plus 2 divided by 3.66, it is 0.54644 plus 3 divided by 5.5, you will get 0.5454. Okay, so these are the sum of the row values, right? But once you get the sum value, you have to divide it by 3. So if I add all these values, 0.54644 plus this is also 3 times 54644, right? So you will get the same value. The last case is it is changed, but the rest of the case you are getting the same thing, I think. Yeah, you will get the value is 0.545. Okay, these values are also same, right? As I have taken only 2 decimal place, you are not able to reflect it, but you will get the same value. 1 by 1.83 same as 2.366 is same as 3.5.5. Okay, now if I sum these values, that is 0.5 divided by 1.83, that is 0.27322, plus 1 divided by 3.66, that is 0.27322, plus 1.5 divided by 5.5, 0.2727. Okay, so if you do so, if you sum these values and divide by 2, divided by 3, this is divided by 3, this is also divided by 3, you will get the value as here 0.81916 divided by 3, so we will get 0.273. Similarly, last one, that is 0.33 divided by 1.83, that is 0.1803, plus 0.66 divided by 3.66 is 0.1803. Okay, plus 1 divided by 5.5, you'll get 0.1818 divided by 3. Okay, if you do so, 0.1803 plus 0.1803, more or less you will get the same thing. Okay, I'm getting here 0.5424 divided by 3. So I'm getting 0.18, right? 180 or 18 I'm getting, right? So these are nothing but the row average value, right? If you take accurate values up to 4 decimal, 5 decimal place, you will get the accurate values. Otherwise, slightly the last digit is going to change. Okay, now we have also considered this one, reputation and location. They are 5 times differing each other. So that student Ram thinks that academic reputation of the university is 5 times as important as location, right? So if I represent that to a matrix A, that matrix A is nothing but 1 and 5. If I consider, let's say, reputation and location against, okay, and if I go for plus 1, that is 1.5 and 1. This 5 times, right? So again, I'm finding the column total. The column total I'm getting here 6. A column total I'm getting here 1 by 2. So if I calculate NA, okay, that is the normalized of this academic, you can say, difference between the reputation and location is the 5 times, right? That's why I'm calculating NA. So NA is nothing but 1 divided by 6, 5 divided by 6, 155 divided by 1.2. Okay, if I calculate this one, how much you are, I will get 0.166. Okay, similarly 1 divided by 5 divided by 1.2, you will get 0.1666, same thing. Okay, then 5 divided by 6, you will get 0.8333, and this is 1 divided by 1.2, so you will get 0.8333. So you can see sum of each and every column, now you can see it is equal to 1. Normalization means what? The sum of each and every column is equal to 1, that you will get here. So now if you see the row average, like in the previous two case, NL, NR case and NR case, you have calculated the row average. So NA case also you are going to calculate the row average. So the row average is nothing but you will get the same thing, right? 0.1666, or you can say it is 0.17. Here also it is 0.833. So you can say 0.83 if you take 2 decimal place. Right? 3 things we have calculated. One is, you can say, normalized location, normalized reputation, and based upon this reputation, that is criteria weight value, we have calculated NA. So if I summarize these values, let me write here. So we have Okay, am I audible? Just let me check. I'm connected. Am I audible, right? Okay. So if you go for weightage of the universities, right? University A, B, C. Now we are finding the weightage of each and every university. So this table we have already calculated, right? So let me fill this value with respect to location. If you go, this is 0.129, 0.129, and this value is 0.2766, 0.2766, or you can write up to 3 decimal place. If you write 277, then 0.594. Okay. Then if you go for reputation, it is 0.545, 0.545. We got here 0.273, and the last one you will get 0.18. If you go for 3 decimal place, it is 2. You will actually get 0.182. Okay, so we also got some weightage value. Okay, weightage value with respect to this location. Location case, we got the weightage value as you can say the weightage value is 0.17. This is 0.17 and 0.83. Right? So now if you calculate the score of alternatives, like if I take alternative 1, okay, then it is nothing but 0.17. I am taking the weight value multiplied with 0.129, this one, plus reputation wise it is 0.83 multiplied with the reputation value, that is 0.545. That will give me the score of the alternative. If I go for alternative 2, it is nothing but 0.17 multiplied by 0.277 plus 0.83 multiplied by 0.273. Similarly, if you go for the last alternative, you can say alternative 3 is equal to, you take weightage value with this one, 0.17 multiplied by 0.594 plus 0.83 multiplied by 0.182. Right? So can anybody calculate and tell me what are the values you are going to get in this case? So you will get 0.17 multiplied by 0.129 plus 0.83 multiplied by 0.545. So I'm getting the value here as 0.4742. Similarly, if I calculate 0.17 multiplied by 277 plus 0.83 multiplied by 273, I'm getting the value as 0.27368. Similarly, if you go for alternative 3, it is 0.17 multiplied by 0.594, 0.83 multiplied by 0.182. So I'm getting 0.25204. So out of these alternatives, which one having highest value? The highest value is having by alternative 1. So the student has to choose the first university based upon the weightage value given by the student. Okay, so for example, if I see here, we have selected the first one, that is the university that is present in United States of America. The student has to select the USA university is the best alternative for these three in comparison to these three universities. Now, if I change the weighted criteria, like here we have taken 5 times, right? So if I change it to 2, if I make it equal, okay, you may get a different calculation. Okay, so based upon the input values, you may find a different value in the case of AHP. Okay, in any method also, if you change the weight value, you are going to get a different value. Okay, but another important thing in AHP, not only this one, you have to find the consistency of the matrix. Okay, you have to find consistency of the matrix. You have find the solution, but you have to find consistency of matrix to say that this solution is acceptable. So in order to find the consistency of the matrix, what you have to do, first you have to calculate the consistency index. Consistency index is nothing but n max minus n divided by n minus 1. What is n max? Let us see what is n max. So n max is nothing but if you take academic location multiplied by W, the weight value. So what is academic reputation? Academic location. Academic location is nothing but this particular matrix. So I'm writing this matrix 1, 1 by 2, then 1 by 5, 2, 1, 1 by 2, then 5, 2, 1. And what is the W value we got here? W value we got here H for location. Location, what is the weight values? These are the weight values. So I am multiplying with it. 0.129, 0.277 and 0.594. Okay. So can anybody calculate and tell me if you multiply these two matrices, this matrix is order of 3 cross 3. This matrix is order of 3 rows and 1 column. So if you calculate, you will get a matrix of 3 cross 1. These need to be same and these are the resultant matrix. So if I take a 3 cross 1 matrix, 3 cross 1 matrix, our result is a 3 cross 1 matrix, right? If you solve this one, how to solve this one? You have to do for the first element, what you have to do? 1 multiplied by 0.129, right? Plus 0.5 multiplied by 0.277 plus 1 by 5 means 0.2 multiplied by 0.594. That will give you me first value. Let me calculate 0.129 plus 0.5 multiplied by 0.27 plus 277 0.277 0.2 multiplied by 0.594. So I am getting the first value as 0.3863. Similarly, second value can be obtained by 2 multiplied by 0.129 plus 0.277 plus 0.5 multiplied by 0.594. So if you do so, 2.129 plus 0.277 plus 0.5 multiplied by 0.594. So you are getting the value as 0.832. So I'm writing here 8320. Okay, 4 decimal place if I take. Similarly, the last value can be calculated as 5 multiplied by 0.129 plus 2 multiplied by 0.277 plus 0.594. Okay, so if I do so, 5 multiplied by 0.129 plus 2 multiplied by 0.277 plus 0.594. It is equal to 1.7930. This calculation 7930. So this value will give you this n max value. So if I calculate n max is nothing but 0.3863 plus 0.8320 plus 1.7930. If you sum these values, you will get n max value. Okay, 0.3863 plus 0.8320 plus 1.7930. So I am getting the value as 3.0113. Okay. So n max is known to you, that is 3.0113. Okay, and you know n value is 3 because you have three different alternatives or three different university divided by 3 minus 1. Okay, so if you solve this one, you will get 0.0113 divided by 2, right? So I think you will get 0.00565. Okay, this is your CI value. What is CI? CI stands for consistency index. This is called as your consistency index. Once you calculate consistency index, okay, then you have to calculate random consistency index. Random consistency index. We can represent it by Ri. Ri is, the formula for Ri is 1.98 multiplied by n minus 2 divided by n. Right? So it is nothing but 1.98, and you know it is three different university. So 3 minus 2 divided by 3. So you will get 1.98 divided by 3. How much you will get here? 1.98 divided by 3. So you will get the value as 0.66. Okay. First you have to find consistency index and random consistency index. Why you are calculating this one? In order to check, here you have seen that alternative 1 is providing you the best value, but whether this particular solution is acceptable or not, for that we are finding consistency index, we are finding random consistency index. Okay, so once CI and RI is known to you, you have to calculate the last value, that is called as consistency ratio. Consistency ratio is nothing but, which we call as CR, is nothing but CI, that is consistency index, divided by RI, that is called as random consistency index. What is CI value we got here? 0.00565 divided by RI. RI is nothing but 0.66. Right? 0.00565 divided by 0.66. How much you will get? So you will get the value as 0.008560 and so on. Right? For this particular calculation, you are going to get 008560 and so on. So what you can conclude here? If CR value is less than is equal to 0.1, if CR value is less than equal to 0.1, then you can say the level of inconsistency, the level of inconsistency is acceptable. So what we can say here, if you see the CR value is less than 1.0, 0.1 or not? Yes, you can see CR value we got a 0.008560. This value is less than equal to 0.1. So as this value is 0.1, we can say the level of inconsistency is acceptable. Okay, the level of inconsistency is acceptable. You can accept the inconsistency. Okay, so whatever solution you have found, this is acceptable. But if it is greater than 0.1, is one side. Okay, other side, if CR value is greater than 0.1, although you have found the solution, the level of inconsistency is not acceptable. Is it clear? So this is all about the analytical hierarchy process. The only part remaining is that we will see the AHP implementation. So in between, if you have any question, you can ask. So let us open MATLAB. I'll show, okay, just a minute. I'll share the code with you because I'll discuss the code, but you can type the code because it is a lengthy code in comparison to other things. Or you can download from the material window. I've shared the link for material. You can go to WhatsApp group, open the material, go to day 7. Under day 7, you can find the files related to AHP and Mura, and download it and open the MATLAB. Okay. Okay, one more time. I have pasted this one in in our group, WhatsApp group. So I have said these files. Okay, let me show here. I have said these files. One is AHP, right? This is a MATLAB file. This is the code for Mura. You can go through it. And these are the sub files. One file consists of the data. Another file contains the aim. Another is contain weight. Let me explain what is this. Let me open NIT weight. So weight means we have considered 4 different criteria, right? One means they are represented in one dimensional, right? Or one different row, right? That's why we say 4, 1. So the weight values are 6, 2, 3, 1. Now, if you open NIT aim, so it is 4, 1, which says that the first 2 attribute, 1 means it is a beneficial attribute, 2 indicates they are non-beneficial attribute. And the next one is NIT weight is over. Okay, next NIT data. So we have considered this data for all the MCDM problem. This data consists of 7 different rows and 4 different columns. So basically it is a 7 cross 4 matrix, right? So all these values are I have represented here. So let us open MATLAB. It will take a little bit time to open the MATLAB. Yeah, first once you download the code, right? I request all of you to see the directory. Directory is much more important here. Just a minute. Yeah, you can see the code is placed in this directory. You have to be note down this particular directory. Suppose you have stored, like I have stored in my Google Drive. That's why it is in this particular path. You go to your this tab and copy this particular path because this path is required to retrieve these files. Okay, so let us open MATLAB. you have to see this is your current folder. So I want to change my current folder to here. Okay. Once I go to the day 7 folder, you can see there is a file ahp.m. I can open it. Okay. Then these are the subfiles which is required to run this code. One is your weight file, another is your data file, another is your aim file, right? So this is the code. Let me run the code. Once you run the code, it is asking me to enter the file. The file is there in this particular directory. I have to copy this directory 1, right? Because although the current directory is changed, suppose I'll write nit weight.txt is the first file. So you will not get error because you have set the current folder to this particular one. Otherwise, what you have to do, you have to paste the entire path. Then you have to mention the file name. For example, I want to give the second file as input, that is called as nit aim.txt. Okay. Then I want to suppose take the third file, which is nit underscore data.txt. So once you run this code, you can see it is showing you the seven different alternatives position, means they are ranked. Like the first alternative is the is ranked 3, second alternative is ranked 6, third alternative is 7, fourth alternative is 4, fifth alternative is 5, sixth alternative is placed as the best alternative, right? And this solution is acceptable. Acceptable means if you calculate the consistency index and random consistency index CI and RI using nmax minus n, which I told you here. Nmax minus n divided by n minus 1 and 1 by 1.98 multiplied by n minus 2 divided by n. And if I divide this CI by RI, so I will get the consistency ratio. The consistency ratio I got here 0.008560. As the consistency ratio is less than equal to 0.1, so this solution is acceptable. So for any data set, if the solution is acceptable, you will get a message here that is accepted. I have written in my code, right? Any type of problem, you can first you have to place the weight values here, whether it is a beneficial non-beneficial attribute in this document, and paste the data here. You will find the alternatives. For example, let us rerun again this file. I want to now give nit weight dot. First one you have to give the weight value. Second one you have to give the aim, whether it is a beneficial attribute or non-beneficial attribute. Now I am giving nit data1.txt. So the difference is that in this data.1txt file you have only 4 alternatives. Okay, I have not considered 7 different alternatives. I have considered 4 different alternatives. So if you check, you can see it is saying out of these 4, the third alternative is the best alternative. Okay, so this particular program takes 3 files as input. One is the weight file, another is beneficial attribute or non-beneficial attribute, that you have to clearly specify. So I'm specifying here as aim and the data file. Once you give this one, it will give you the rank of each and every alternative, and it will say you whether this solution is acceptable or it is not acceptable, right? That you will get. Let us go to the code first. Okay, I'll tell you the details of this particular code. I told you in the last class also, CLC clear all close all is there to clear the command window, workspace, and close any unnecessary files. Then it will display a message that is AHP, and it will ask you to enter a file. The file which you have entered, that is going to store in the weight matrix. Okay, let us go to the weight matrix and understand what is there in the weight matrix. If I show you the workspace, it is more clear. So this is the weight matrix. Okay, the weight values we have taken 6231, so that is available in the weight matrix. And I consider T weight. T weight is nothing but there are 4 weights. M weight is nothing but 1. Means M weight means number of rows you have given the weight, that is 1, and number of weights is equal to 4. So it is simply a 4 cross 1 matrix, one dimensional matrix. Now this is for a file input. Okay, it is asking the second file. The second file is stored in AIM matrix. Okay, if I open AIM matrix, so let me open the AIM matrix. In AIM matrix, it is showing 1122. What is 1122 indicates? 1122 indicates the first 2. 1 indicates beneficial, 2 indicates non-beneficial. That means first 2 are beneficial attribute, second 2 are non-beneficial attribute. Right? Again, as I am asking a file input, when the user is giving the input, I store in the data. So if I open the data here, where is the data? Okay, data here. So that contain 4 different alternatives performance values. That is, these are the 4 different alternatives. These are the 4 different criteria, and I am giving the performance values. Is it clear? Now what we are doing here? First, I am calculating the weighted pairwise comparison matrix. So I am doing weight normalization. I am storing in N weight. So let us go to N weight. Let us see what is there in the N weight. N weight is nothing but it is a pairwise comparison matrix. So you know the weight values are 1, 3, 2, 6, and you can convert it into a pairwise matrix, which will come as a 4 cross 4 matrix. Right? So I have written the code, this one for that. Then I have to find the column sum. You know, we find column sum. Column sum is nothing but 1 plus 0.3333 plus 0.5 plus 1667. And the column sum you can find COL SUM, another matrix, right? So if you open COL sum, it is saying the column sums are 2, 6, 4, 12 respectively. Column sum is done. Now I am finding weight. Okay, so NN weight, it is nothing but the ratio of N weight and column sum. You have to divide it again, right? Normalized weight, which we say normalized weight. If I go for NN weight, you can see these are the normalized values. Okay, just like you done academic reputation normalized matrix, academic location normalized matrix, I am doing the same thing here. After that, finally, we have calculated the row average. If I calculate the row averages are 0.51, 0.1667, 0.25, and 0.0833 respectively. Right? Row sum is calculated. Row average is calculated. Okay, once row average is calculated, that is completed the process of weight pairwise comparison matrix. Let us proceed to the second one, that is called as value pairwise comparison matrix. So you are given with the set of performance values, right? That is alternative against the criteria. So you have to calculate N data, normalized data. If you go for N data, it is a 3-dimensional matrix. You can see the 3-dimensional matrix, right? You will find for as there are 4 different alternatives. You will find one 3D matrix of size 4 cross 4 cross 4. Okay. After that, I am finding again the column sum for these values. So I am representing as a COLL sum. So if I go for column sum, these are the column sum values of these 4 different alternatives against 4 different criteria. That is 4 different 16 different performance values are now normalized. Their column span is also calculated. Then finally, what you have to do, you have to calculate the row average value, right? If I go for ROWW, I have represented extra W to take the row average value. These are the row average values, right? Because it is three-dimensional matrix, that's why you are getting a two-dimensional values here. Okay, after that, what we have to do? Row average is multiplied with the WW average. Okay, both average need to be multiplied. After multiplied, I have sorted them to report which alternative got which rank. So for that, I have written here. And finally, the best alternative is going to be displayed. And I'm going to calculate n weight into row average. That will give you the consistency, which we have calculated as a consistency index. Right? Consistency index is nothing but CI. In order to calculate CI, you need to calculate first this one, consistency. Then you can say n max, or sometimes we call this the lambda max. Lambda max minus number of samples or number of alternatives divided by n minus 1. So that will give you CI. Similarly, Ri is nothing but random consistency index. It is nothing but 1.98 multiplied by n minus 2 divided by n. So CI-Ri is calculated, then CR is calculated as CI divided by Ri. Okay. So once you calculated CI-Ri, if the CR value is less than equal to 0.1, the solution is acceptable. But if the value is greater, then we can conclude the value is not acceptable. Right? Like if you want to take more values, like I'll give you an example. The main purpose of going for MATLAB is that it can take a large amount of data also. Like I have taken a simple example where I have taken 7 different alternatives. So let us generate okay, another set of alternatives. For example, I want to go for 100. Let's say in the range of I'm taking, let it be 1 to 100, 1 to 100. Okay, and I want to generate 100 different alternatives with 4 different criteria. Okay, so and let me store it in X. Okay. Sorry, I missed the integer. Okay. Now X contains your 100 different alternatives. Okay. Let us copy this data, 100 different alternatives data. I have copied all the 100 different alternative with 4 criteria value. I want to save it as, let's say I want to save as NIT underscore data 2. Okay. I have saved this value. Now I can run this algorithm. If I run it, it is asking me the file. I am saying the first file is same, that is NIT weight.txt file. Second file is NIT, you can say it is aim.txt file. Third one is, let's say, file that is data2.txt file. Okay, assignment has more singleton. Okay, I have not mentioned the size of this matrix. That's why it is showing error. So let me give the sizes 100 cross 4. Okay? Because 100 different rows are there, 4 different columns are there. First, you have to give the index. Otherwise, it will show an error. Okay, let us rerun AHP. Give NIT weight.txt. Give NIT aim.txt, NIT data2.txt. So it is giving that these are the best alternatives you are getting, 85, 9, 26, 10, and their respective alternatives, right? And the solution is also acceptable. The solution is acceptable, right? So we are showing at the 5 different alternatives. but you can show if you want you want to know the rank of each and every alternatives, you can also show that one. But I have taken only 10 for this particular code. That's why it is showing only 10. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And you can see the sixth alternative is ranked 2. So it is the best alternative out of that, after this particular data set. Okay, I have set this code. You can utilize this code for your respective you can say respective research domain. You can apply analytical hierarchy process to solve the problem. Okay, so this is all from my side related to Mura and AHP, implementation of AHP algorithm, as well as hands-on calculation on AHP numerical example. So if you have any question, you can ask. Is there any question? Anything?
Hello.
Yeah, Samim sir, please.
Yes. So thank you very much for your excellent lecture and showing us the way how to calculate this AHP method. I mean, here in MATLAB. But sir, whatever the other methods, how we can calculate them through MATLAB or in Excel? Would you please be kind to show us some, good reference material for that? Thank you very much, sir.
I have done all the coding in MATLAB only. So
Okay.
Mura code I have already given to you in the Google Drive file, that
Okay.
group file where all the materials are there. So you can run the
Okay.
code by giving these files as input. One is weight file you have to give input, and whether it is beneficial or non-beneficial, and performance
sir.
measure, that is data file. If you give, then you
Okay,
can
sir.
get the output.
Okay, sir. Sir, so I mean, for Excel, I mean, is there any kind of resource material or some good reference book so that I mean that could be helpful for me to practice?
Yeah, I will share that link. Today morning only I have searched related to this AHP, how you can do AHP, especially AHP and ANP methods in a Microsoft Excel. So I'm sharing
Okay.
that link with you, in the chat box as well as in WhatsApp file,
Sir, it
WhatsApp
would be better
group.
if you please be kind to share them in WhatsApp group. Yes, sir.
Yeah, I have shared in WhatsApp group also.
Okay.
Now you can check. You can go
Okay.
through this tutorial. This gives the details that how you can find the best alternative, how you can take a decision using analytical hierarchy process.
Okay, but sir, I mean, that's just I mean one process. But what about the others?
You have to write the code for your own, sir. You have to write for each and
Okay.
every one. You have to write the code. Some
Okay.
data analysis tools supports AHP and P, that what you mentioned. Microsoft Excel is providing that one, but not all methods.
Okay. Okay. Sir, if you please don't mind, may I
Yeah,
ask a question?
yeah. Please.
Thank you very much, sir. Sir, my humble request to you is that as per here in this, FDP
Yeah.
program, we are learning about so many optimization methods. But sir,
Yes.
I'm actually, considering this thing again and again that I'm not an engineer. I have come from the field of management. But
Yes.
this method it's actually very much relevant for managerial decision making. So that's why I'm
Yeah.
requesting that what actually the way what method I should use in particular scenario. I mean, the precise question is that when to use which method.
No, there is no clear-cut answer for this particular question that I cannot guarantee you that AHP will work irrespective of the problem domain. It is
Okay,
just like a
okay,
hit and trial method you have to apply. Suppose you are aware of now these two sessions I told you about 8 different methods. So
yes,
maybe
sir.
if you other speaker, they may be focused on other type of method which they have experienced as a part of their work. So you have to try this thing. You have to go to literature. You have to see that what are the other methods that is applied in your literature. and those methods are not applied, that you can try and see the performance. Then only you can say that yes, this method is a better one in my research domain.
Okay. Okay. I totally got it, sir. Thank you very much, sir.
Yeah, yeah, yeah. Yeah, any other question? There is no question, then thank you everyone for patiently listening me. Our next speaker, Dr. Love Kumar, already joined. So we'll start the next session after 5 minutes. So take a break of 5 minutes. Then Dr. Love will discuss about the case study of genetic algorithm with implementation details. So you can see how genetic algorithm can be applied in a particular case study. Okay, thank you everyone. Yeah, welcome to the second session of day 7. So in this session, we have Dr. Lab Kumar from NIT Kurukshetra, and he will discuss about the case study using genetic algorithm. So before Dr. Lab will start the session, let me introduce Dr. Lab Kumar. So he is currently working as an assistant professor in the Department of Computer Engineering, NIT Kurukshetra, and he worked as assistant professor in the Department of Computer Science and Information System, BITS Pilani, Hyderabad campus. He also received his PhD in Computer Science and Engineering from NIT Rourkela under the supervision of Professor Santanu Kumar Rath. His current research interests are in the area of mining software repositories, machine learning, text analysis, testing of artificial intelligence systems, software analytics, and social media analytics. His thesis is titled Predicting Software Quality Parameters Using Artificial Intelligence Techniques and Source Code Matrices. He was a faculty member at Thapar University from August 2017 to December 2017. He has delivered more than 50 invited talks, over 80 international referred publications in international conferences and journals, and published two book chapters to his credit. He won several other awards, including the Best Young Scientist Award, Best Researcher Award, and Best Paper Award. So with this brief introduction, I request Dr. Lab Kumar to start the session.
Yeah, thank you, sir. Thank you, sir. So first I'm going to present my screen. Okay, so first I'm going to share my screen. Yeah, can you please check, sir? So it is visible. Anyone? Can you please check?
Yeah, now it is visible.
Okay, sir. Thank you. Yeah. Okay, so good evening, everyone. So in this session, basically we will go with the application of genetic algorithm for feature selection. And parallelly, we will also compare with some other feature selection technique. And we will see what is the importance of using feature selection, why we will use the feature selection. And if we are using the feature selection, what are the benefits we will get after using this feature selection. So these are the seminar outlines. So first we'll go with the introduction, then feature selection method. Then there are two different category of feature selection. One is called feature ranking and second one is feature subset selection technique. So we will write the code for both feature ranking technique as well as the feature subset selection technique. Then we will also go with the principal component analysis. So some case we are also changing the value of the feature to get the better visualization. So basically we will go with the principal component analysis and we will also check what are the benefits we are getting when we are using the principal component analysis. Then next one we will go with the genetic algorithm and finally we will write our code and based on that we have to make our conclusion which types of feature selection technique is best, whether the feature ranking is best, feature subset selection is best, PCA is best, or genetic algorithm is best. But again, it will totally depend upon the domain. So we cannot say like that maybe for our domain, PCA will give you the better result, but maybe for your domain, genetic algorithm will give you the better result. It will totally depend upon the types of the data set and based on that, it will give the performance. So basically we know before going to the data mining application, if you are planning to apply any ML approach or if you are planning to apply any data mining technique, before that we are going for the pre-processing phase. Before that we have to pre-process the data and after that we are going to apply the machine learning algorithm or data mining algorithm. So basically the objective of the feature selection technique is to remove the irrelevant feature. What are the features that is not important for particular objective? We have to remove it. And after that, we have to use only those number of features for our analysis. So here, basically, what will happen like that, if we are going to decrease the number of features, definitely the complexity of the model will reduce it. So here, this is the main objective of the feature selection technique. So there are two different type of feature selection techniques. So same like that, I think you are the instructor, you are the faculty. If someone will ask you to select top 5 students, so definitely you have to process Either you have to follow the first method where you are going to conduct some type of exam, and based on the exam, you are going to sort all the students, and after that, you are selecting the top 5 students. Maybe you are doing the sorting based on some quiz exam, based on some compre exam, based on some CGPA, based on the 10th marks, based on the 12th marks. So in the feature ranking technique, same like that, we are using some parameter, and based on that, we are going to rank the feature, and after that, we are selecting the top 5 feature, top 10 feature, top 20 feature. Based on our requirement, we are selecting the number of feature. But if we are going with the optimal number of feature, then we are selecting the log 2 base n number of feature. If we are working with the 10 feature, we have to select that log 2 base 10, and that value may become 3 point something, but we have to consider as a 4 feature. We will not consider all 10 feature, we will only consider 4 feature. So if you are working for the 1000 feature, we have to only consider the optimal number of feature as a 10 feature. But maybe we will change. But if we are going to increase the number of feature, definitely maybe the performance will improve, but parallelly it will also improve the complexity of the model. So here we can also use some type of cost benefit analysis. So how much cost we are investing and how much benefit we are getting. So based on that, if we are going to take the optimal number of features, then it was observed like that log 2 base n number of features. That is the first approach. But in this case, what we are going to do, we are selecting the top 5 students. Now assume that if we are planning to, now some like that IIT Kharagpur is going to organize one event for programming context. So where they are giving some type of requirement, and after that, for a group of student, means we have to send one group of student, and that will appear for IIT Kharagpur one test, where they have to solve some problem. They will get the requirement, where they have to solve the problem, and after that they have to explain it. Okay. If you are using the feature ranking technique, what will happen like that? We have to select the top 5 students. Maybe the all 5 students belongs to one category. All 5 students very good in coding, but they have no any idea about how to handle the requirement, how to present the requirement. They have no any idea. But if we are coming to the feature subset selection, we are finding the best combination of this. So what I have to do in the feature selection technique? Basically, we are going to make the group inside the class. We are going to make the group, and we are giving the similar types of tasks. And after that, we are going to find which group have the better. Same like that, if we are working for the cricket team. In the cricket team, we are using the feature subset selection technique. We are finding the best combination of team. Best combination of team means definitely it is a collection of 4 batsmen, it is a collection of some bowler, all-rounder, wicket-keeper. That one will consider as a best collection of team. But in the feature ranking technique, it is not like that. Based on the ranking of the player, we have to select the top 11 players. That is not the right approach. So some case the feature ranking technique will give you the better result, but most of the cases feature subset selection will give you the better. But the problem is it will take more time to find the best combination of features. Because if you are working with 4 features, what we have to do, we have to take the all combination of 4 features. First, we have to take with 1 features, then we'll go with the 2 features, then we'll go with the combination of 3 features, and finally we'll go with the 4 feature. And based on that, we have to find which combination is giving the better. That is possible if you are working with the small number of features. But when you are working with the large number of features, that is not possible. We have to not use the brute force approach. So in this case, basically, we have to use the concept of genetic algorithm. So in this session, basically, we will also focus on genetic algorithm, how we can use the genetic algorithm for feature subset selection, how we will find the best combination of features using the genetic algorithm. This is our proposed method. During the PhD, I have proposed this feature selection method, and here we will use only one step of feature selection. So before going to the final, before applying the feature ranking technique and feature subset selection technique, first we have to also check whether the individual feature have the ability for prediction or not. So as for example, if you are working for job recommendation system, then in this case for every feature, so as for example, student ID is not an important feature to decide whether the student will get job or not. CGPA is an important feature. 10th marks is an important feature. 12th marks is an important feature. So basically what we are going to do, we are going with the individual feature, and based on that, we are going to check whether this feature had the ability to differentiate the 2 different classes or not. Okay. So here we are using some type of hypothesis testing. So our main objective is, if we are working for binary classification, If you are working for multi-classification, that we can also use. But in this session, whatever the data set we have considered, all data belongs to two categories, means binary classification, where output will only contain 0 or 1. So 0 means you will assume like that we are working with, now I'm going to share you the data set. So I have shared all the data set in one folder. The name of this drive is NITK, and where I have written the 51 different data sets. If you are going with each data set, that will contain some features. And the last column basically contain the level, okay? And you will assume like that this level basically belongs to 0 means the students are not waiting for the job, and 1 means the students are still waiting for the job. So this is a simple data set. And these are the characteristics related to the student. So maybe we'll consider like that number of subjects registered by the student, how many times the student got the A grade, something like that. These features are there. Lastly, I will tell you what is the data set. This data set is clear. But now we'll assume like that this data set totally related to 51 different colleges. And for each college, basically the first 20 are the feature totally related to the student. And the last column basically contains 0 or 1. 0 means the students are not waiting for the job, and 1 means the students are still waiting for the job. Now our objective is to develop one model, and that model will predict whether the student will get a job or not. It will only predict a two value, 0 or 1. 0 means the student will get job, and 1 means the student will not get job. This is our final objective. Now, in this case, our first objective is to find whether the feature number A is important or not. So what we are going to do here, if we are going to check what we are going to do, we are doing the simple. First, we are finding what are the ID of the student and what is the ID of the student who is not getting the job. So simply in the class, what we are going to do, we are going to differentiate the class into the two different groups. One group who is getting the job, and second group who is not getting the job. Now after that we are asking what is the CGPA. Now for example, we are getting 8, we are getting 7, we are getting 6.5, we are getting here 7.8, something like that. So after that what we are doing, we are writing what is the CGPA of the student who is getting job and what is the CGPA of the student who is not getting. Then after that, we are going to find if there is any difference between the CGPA of the student who is getting the job with CGPA of the student who is not getting the job. If there is no any difference, in both the cases, we are getting the same type of CGPA, means we can say CGPA is not an important feature. Again, try to understand what I am saying. First, simply we are doing like that. First, we are finding what is the ID of the student who is getting job, and what is the ID of the student who is not getting job. This is our first objective. After student means what are the CGPA of the student who is getting job, and what are the CGPA of the student who is not getting job. And then we are finding the difference. If there is difference more than 5%, if you are working for 95% confidence interval, if there is difference is more than 5%, then in this case we can say this is an important feature. But now assume that in both the cases we are getting the same difference, we are getting the similar types of CGPA. Means this is not an important feature. Company is not looking the CGPA, company is looking some other parameter. Such for example, now assume that we are going to write one simple code here. Okay, so now you can see. So here we are using the Google Colab. Okay, if you want to share, I will share the code with you. So simply you can write here. There is no need to install the Anaconda in your system. Directly you have to write the code from here. Okay, but before that, first I'm going to write some simple code. Okay, before writing the code. Okay, as for example, first we have to upload the data in our Google Drive, and we have to give the permission. If you are going to check, this is the permission we have given to the access our drive. Then after that, we are giving the file location where the data is present. So our data is present in NITK folder, and there where we have written the 51 different colleges data. Now after that, if you are going to read the data, we are using the np.generate from text, or you can also use the pandas library, or you can use the numpy library. But this is the method that is used to read the data from .csv file. So if you are going to check here, if this is our data, if you are going to check, this is our data. It will print. This is our data. If we are going to find what is the number of students, simply we have to write np.save. If you are going to write, it will return what is the shape. Now you can see we are working with first college with 125 student with 21 feature. 21 feature means 21 means out of 21, 20 are the feature, and one is your whether the student is getting job or not. Okay. Same like that, if you are going to access the first feature value, so we have to write here 0, then it will give you only the first feature value. What is the first feature value of all 125 students? Now you can see this is the first feature value for all 125 students. Same like that, if you are writing 1, it will give you the feature number 2, because the index will always start with 0. If you are writing here -1, it will start from the last column. Now you can see these are the statistics of the student who is getting job and who is not getting job. So 0 means the student is getting job, 1 means the student is still waiting for the job. So here I have clearly mentioned, if you are going to find the shape of the data, you can write np.shape. If we are going to print a specific column whole data, then we have to write column, and here we have to write which column number, and numbering will start with 0. Now, if you are going to search any values, if I am going to find how many students who are getting the job, we will write in1 equal to np.where. np.where we have to write data of all column -1 double equal to 0. If you are writing this one, yeah. So if we are writing this one, basically it will give you what are the ID of the student. If you are going to check in1 of 0, it will give you what are the ID of the student who is getting job. Now you can see these are the ID of the student who is getting the job. If you are going to check 0 number job, 0 number student is getting job, first number student is still waiting for the job, 2, 3, 4. Now you can see it, we are getting the same value. If you are going to check, we are getting the same value. So if you are going to search any value, what we have to write np.where. Okay. Now we done the code. Now we are going to write here our final code. So what we are going to do here, we are going to define one function. So we are defining one function called important feature, where we have to pass our whole data and it will return what are the important features. So we are defining one function. What is the name of the function? Important feature. And where we have to pass the whole data. Whole data means the last column basically contain whether the student is getting job or not, and the rest of the column will contain features. Now we are going to find which feature has the ability to differentiate the student is getting job with student is not getting job. So what is the first step? First we are finding what is the ID of the student who is getting job. So we'll write np.where data of all column -1 double equal to 0, and now we are writing in2 equal to np.where data of all column -1 double equal to 1. So first we are finding what are the ID of the student who is getting job and what are the ID of the student who is not getting job. Once we got this value, now we already know for every college we have the 20 features. So for every feature we are going to calculate what is the p-value. We are using one concept that is called the ransom test. That is called the ransom test. Okay. The ransom test basically used, if we are going to use this one, it is basically used to find is there any difference between the two sample or not. If we are getting the p-value less than equal to 0.05, means there is a difference. Otherwise, there is no any difference between the two samples. As for example, now you can see, as for example, here I'm going to write a equal to 2, 3, 4, 5, 6. And then we are writing here b equal to 2, 3, 4, 5, 6. We are writing 2. One is your a, and second one we are writing b. After that, if we are going to check, we are going to use here. Let's see. We are going to use here ransom test. Equal to ransom a comma b. If you are going to check here p-value, now you can see basically it p-value is coming p.p-value. If you are going to type, it will give you, now you can see it is giving the value equal to 1. Means if the p-value is coming greater than equal to 0.05, Means there is no any difference. Now you can see here we are getting the p-value greater than 0.05. Means there is no any difference between the A and B. If I am going to change this value to 12, 13, and this one we are writing 44, this one we are writing 55, and this one we are writing 66. Now you can see what value we are getting here, because these are the less. Now you can see value we are getting less than 0.05. Means there is a difference between A and B. Now you can see there is a difference between A and B. If we are giving the same value, the value of P will come greater than 0.05. So here we are using the same concept and we are going to calculate the P value, and based on that we have to decide our features are important or not. So here we are writing P value equal to, we are going to take one variable np dot 0, and here we are writing 21. Now what we are writing here, first we are going to assume like that all features are important. So we have taken one variable, simple like that. If we are writing the C, what we have to do before going to store the value, first we have to create the variable. Here we have created one variable called PV, and where we have written all the values equal to 0. Now for every feature we are going to calculate. So for I 0 to 20, because we are working with 20 feature, and then we have to calculate P value equal to rank sum. Rank sum, we are working with first data, first feature. So we'll write here in1 of G, comma, first feature I, comma, data of in2 of 0, comma. If we are going to check what we are doing like that, when the value of I equal to 0, we are working with first feature, and then we are finding what is the value of the first feature for a student who is getting job, and what is the value of the first feature for the student who is not getting the job. And then we are finding is there any difference or not. Means we are going to store the p value of I equal to p p dot p value. So p dot p value. So we are only going to store the p dot p value, and finally we are going to return. Return p v. Now you can see we have written one function that is basically used to calculate for every feature. It will calculate what is the p value. Now we have to check whether this function is working or not. So we are writing p equal to imp FEAT feature of, we are passing our data. Now we can see it is working. If we are going to check, this is our p value. Now you can see. So if we are going to check what, in some cases we are getting the p value greater than 0.05, and some cases we are getting the p value less than equal to 0.05. If I am going to find here in1 equal to np dot, where p value is smaller than equal to 0.05. Now you can see out of 20 feature, if we are going to check, these are only important feature. If we are going to check out of 20 feature, only this feature 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 20 feature, only the 12 feature had the ability to differentiate the student between the placement and non-placement. Rest 8 feature, the students are getting the same value. So maybe if we are going to consider the age, we are getting the similar types of age for the student who is getting job and for the student who is not getting. So now we have done for one data set. Parallelly, we will apply for all 51 data set, and we have to save our data in our same folder. So now what we are going to do, we are working with how many data set? 451. So we are writing for I in range of 0 to 51. Because we are working for 51 data set. If we are going to check here, the numbering of the data set starting with 1, it is not starting with 0. But when you are writing the range 0 to 51, it will vary between 0 to 50. So we are writing here file name equal to file location plus str of I plus 1 plus .csv. When the value of I equal to 0 means we are working for first college. When the value of I equal to 1 means we are working for second college. When the value of I equal to 2, we are working for third college. So we have written the file name. Once we got the file name, we are going to read the data. np dot generate from text. If you're writing generate from text file number and the delimiter is equal to comma. Once we got the data set, we are going to write p equal to important feature. We are calling our function called important feature. Whatever the function we have written, IMP, important feature, and here we are passing our data. Once we got this value, now we are finding how many features are important. NP dot where p value is smaller than equal to 0.05. Once we got this value, p value is smaller than equal to 0.05. Now we have to prepare our new data of all row comma in1. Means we are taking only those features where p value is smaller than 0.05. Once we got this value, now we are going to save our data. So we are writing file name equal to file location plus str of 51 plus dot csv 51 plus I plus 1. So what we are writing? So what we are going to do? We are going to save our file with 52. So 52 basically contain 52 files basically contain what are the important feature for college number 1 using rank sum test. So that we have stored in 52. Same for 53, that is related to college number 2. 54, that is related to college number 3, something like that. Now we are going to save np dot. So I have written the simple code here. If we are going to save the file, we have to write here np dot save text. So the code basically we have to write. Same code is there. So file name, we are going to save the data in, and then we are writing comma delimiter. If we are going to find how many features we are getting important, so we have to also print here, print important feature for college, comma str of I for college I, comma str of len of in1 of 0. So basically we are going to print this value also. So for college I, what is the number of important features? So here we are also writing something. Now we have to check whether it is working or not. So first we have to execute the code. Now you can see it is working. If we are going to check carefully for college number 0, means college number 1, 13 features are important. College number 2, only 3 features. So out of 21, only 3 are the important feature. Now you can see 14. For every case, if we are going to check, there are some features that is irrelevant, that is not important to decide whether the student will get a job or not. So now you can see this is already completed. If you are going to check here, if I am going to update this folder, I am going to refresh it. Now you can see it generated the 51 more files. Okay, and what are the 51 more files? Basically, it will contain, if you are going to check, it will not contain all 21 features. It's only containing those features that is significantly or that have the capability to distinguish between the places student and non-place student. So this is the initial point of any feature selection technique. So if you are planning to apply feature selection technique, the first approach, you have to check whether this feature is important for your objective or not. Because when we are preparing our data warehouse or when we are making our data warehouse, we are making for multiple purpose. We are not making for single purpose. So in this case, we are going to store all the information related to the student. But when you are going for the analysis, not all the informations are important for this analysis. Only some part of the informations are important. So here, basically, we are using this type of concept. Okay. So here you can see I have also written the formula for confidence interval x mean plus minus j into standard deviation divided by square root of n. You can also use this formula to calculate the value, or directly you can use the rank sum test. And here I have also written the code. So either you can use the rank sum test or you can use the different type of hypothesis testing. So either you can use the test, t-test, the rank sum test, ANOVA test is also there. So but basic objective is to test that whether the two sample, so what are the value for the feature if the student is getting job, and what are the value for the feature if the student is not getting job. Our main objective is to check if there any difference or not. If there is a difference, then we can say there is an important feature. Otherwise, there is no important feature. Now, after that, the next task is your feature ranking. I have already discussed. So there are two different ways for feature selection. One, exam for every student, and then you have to rank the student based on that, and you have to select the top 5 students, top 10 students, top 20 students, or you have to select the Optimal case, log 2 base in number of students. So here we will also discuss one technique that is basically used for feature selection. So the one simple approach that is called the Gini index. We are going to calculate the Gini index, and based on that we have to find which feature had the more prediction ability, which feature had the better for job recommendation system. And the formula is very simple. We are going to calculate the Gini split equal to I equal to 1 to K Ni by N into Gini of I. And final Gini split equal to 1 minus summation of I equal to 1 to K P of J by T whole square. Now we'll see how to calculate. We will see here. So I have taken one simple example. I think you are very much familiar with this example. So what we are going to do, we are going to use one simple example where we have taken the three features. One is called the refund, second one is called the managerial status, and third one is called the taxable income. And based on that, we are going to predict whether this is something related to cheat or not. So we have the cheat equal to no or yes. So now we are going to find which one had the more power, which one had the better ability of prediction, refund or managerial status or taxable income. So the first is how we can find. First, the simple approach. Here what we have to do, first we have to find what is the unique value of refund. Here we are getting the two unique value. Mainly this approach will work for discrete data. It will not work for continuous data. If you have the continuous data, first you have to convert to the discrete, and then this method will work. So as for example, now I am going to see like that. So I have taken one simple example. For example, I am taking here CGPA. After that, you will say 10th marks. And third one, we have taken the 12th marks. Okay. Now you can see what we have written here. Here we have written the high CGPA and the low CGPA. I'm going to increase the font size. So I think it is visible. So high CGPA, low CGPA, high 10th marks, low 10th marks. Then we are writing high 12th marks, low 12th marks. So here you can use some formula. You can use some threshold value. If the CGPA of the student greater than 8.5, we will consider as a high or we will consider as a low. If you are going with the more optimal, you can use some clustering algorithm. K-mean clustering we can use, hierarchical clustering you can use, or you can use the fuzzy C-mean clustering. So any clustering algorithm you can use if you are going with the more optimal way. But if you are going with the simple way, you have to simply find what is the average CGPA of the student. And what are the students whose CGPA is greater than average, that we will consider as a high CGPA, otherwise consider as a low CGPA. So now we do that, what we are getting like that, for high CGPA, if the student had the high CGPA, 10 students are getting job and 10 students are not getting. Again, if the student CGPA is low, we are writing 10, 10. We are writing some statistics. Here we are writing 20, 0, and here we are writing 20, 0, 20. Here we are writing something called 15, 5, and here we are writing 5, 15. They have given you one statistics. What we are writing like that, the students CGPA is high. 10 students are getting job and 10 students are not getting job. Same like that, if the student CGPA is low, 10 students are getting job, are not getting job. Going for the 10th marks, what I am saying like that, if the student 10th marks is high, 20 students are getting job and 0 students are not getting job. If the low, what I am saying like that, 0 students are not getting job and 20 are. So now you can see, if you are going to get the 10th marks, 100% you can decide whether the student will get job or not. There is no any confusion. Now you can see 20. If the 10th marks is high, all 20 students are getting the job. Same like that, if the 10th marks is low, what I'm saying, all 20 students are not getting the job. But if we are coming to the CGPA, we can say this is the worst feature, because we are saying 50-50. If the student CGPA is high, 50-50 you have the chance to get job. That is not considered as a important feature. If you are going to check, because the 50-50 is the worst case. Even if you are saying 60-40, that is better than 50-50. But in this case, what we are saying like that, 100-100. Now we will see the low value of Gini is best or high value of Gini is best. How we can calculate? Simple. First we have to calculate what is the probability of the student who is getting job if the CGPA is high. So what is the probability? 10 divided by 20, probability is 0.5, and this probability is also 0.5. If we are going to this side low, probability is 0.5 and this probability is also 0.5. So first we are calculating the probability. If the CGPA is high, what is the probability of the student who is getting job, and what is the probability of the student who is not getting? So we are getting 50-50. Now you can see the formula. So what we are writing? If we are going to calculate the Gini for each feature, 1 minus I equal to 1 to k, P of j by t whole square. Means basically this value is nothing but 1 minus 0.5 into 0.5 because whole square minus second one is also we are getting 0.5 into 0.5. Whatever the value it will come, this is the Gini of high, and same like that we will calculate the Gini of low. Same like that if we are going for this case, what is the probability, 1 or 0? What is the Gini value? We'll get 1 minus 1 square, that is 1, minus 0 square, we will get the value equal to 0. Now you can see if we are getting the lower value of Gini split, that will basically represent the best feature, because now you can see higher value we are getting in this case. What we are getting 1 minus 0.5 into 0.25. So this value will come 0.5 and this value will come. Now we will take one simple example how we will work. Now you can see for this one, first step we have to find the unique value of refund. What is the unique value of refund? 2. One is called yes and second one is called no. So we have to write here yes and second one we have to write here no. Approach is very simple. So first we have written yes no. After that we have to find how many cases we are getting refund equal to yes. 1 case, 2 case, 3 case. Out of 3 cases, how many cases we are getting the cheat equal to no? First case no, second case no, third case no. So we have to write here for yes the cheat 3 case no and 0 case we are getting yes. So here we are writing cheat equal to no and cheat equal to yes. Now we will come to the next one. How many cases we are getting the refund equal to no? 1, 2, 3, 4, 5, 6, 7. Out of 7, how many cases we are getting yes? 1, 2, 3 cases. So we have to write here 3 and we have to write here, sorry, here no. So we have to write here 4. You can see. So this is the diagram. After that we have to calculate what is the Gini value. So first we will calculate the probability. What is the probability of cheat when the refund equal to yes? Probability is 1. This one is 0%, and here probability become 4 by 7, and this one become 3 by 7. 4 divided by 4 by 7. Now you can see if you are going to calculate Gini value, because this is the best case, Gini value is 0, and in this case what value will get? 1 minus 16 divided by 49 minus 9 divided by 49. If you are going to calculate the value, it will come 24 divided by 49. The Gini value. Overall Gini value is nothing but equal to the number of sample belongs to this category 10 into 0 plus 7 divided by 10 into 24 divided by 49. This is the Gini split value, and the lower value of Gini split basically represent the best feature. Here I have clearly mentioned. So now in this way we are calculating the Gini value, and based on that we are going to sort. Based on that we are going to rank all the features, and after that we have to select, because we are working for 20 features, so we have to select the top 5 features. Now again we are going to write one code for Gini split. I have already mentioned it will only work for discrete data. It will not work for continuous data. So again I am going to say like that. I am going to write one code for Gini split. So we are writing here Gini, define Gini value. It will basically calculate Gini value, and here we will pass the features and we have to pass the label. We have to pass feature and label. But in my case, what we are getting? In my case, we are getting the feature in continuous value. So here what we have to do? We have to use some type of clustering approach. So here we are using, for your case, I am going to use one simple approach. Now you can see k-mean clustering, and here we are going to apply the k-mean clustering, and we have to take the labels. What we have done, if we are going to check here, what we have done here, we are going to apply here k-mean clustering on feature F, and after that we are going to find here k equal to, we are writing labels. Okay, So basically it will return what are the value we are getting high and what are the value we are getting low. Okay, and we have applied the 2 k-mean clustering. You can also apply 3, you can also apply 4. Okay, but why we are applying? Because we are going to calculate the Gini value and it will only work for discrete data. So either you can use threshold value, or either you can use average value, or you can use the k-mean cluster. If you are going for the optimal case, you can use the k-mean cluster. Now you can see after that, what is the first approach we are doing? First, we are finding how many cases we are getting the refund equal to yes and how many cases we are getting the refund equal to no. Means first we have to find what are the student whose feature value is coming high. Feature means CGPA. So we are finding here IN1 equal to NP dot where we are getting K equal to 0 means low, and then we are writing IN2 equal to NP dot where K double equal to 1. So first we are finding what are the ID of the student. Try to understand what I am saying. What are the ID of the student whose CGPA is low and what are the ID of the student whose CGPA is high. The same thing we are finding here. If we are going to check how many cases we are getting refund equal to yes. For those cases, how many cases we are getting cheat equal to no and cheat equal to yes. Means again we have to find if the student CGPA is low, how many student who is getting job and how many student who is not getting job. So we are writing the job statistics for 0 means if the CGPA is low equal to feature value means equal to LAB because the label basically contains job IN of 0. Now you can see same like that. What I have written, job statistics of 1 equal to LAB IN2 of 0. Now you can see what I have done. I have calculated what is the job statistics of the student whose CGPA is low and what is the job statistics of the student whose CGPA is high. Once we got this value, now we have to calculate how many cases the student is getting job if the CGPA is low, not getting job. So here the simple way you can also calculate, simply you will find the sum. If you are going to calculate what is the sum of job 0, basically it will represent these are the students still waiting for the job. So here we are finding number of students whose CGPA is low and still waiting for the job equal to NP dot sum of job 0. Number of students whose CGPA is low 0 not waiting for the job equal to whatever the value we have to subtract it. So length of IN1 of 0 minus N0 1. Because we are writing 0 or 1, so simply we are counting the sum. If the sum value is coming 5, so 5 students are waiting for the job. And what are the total number of students? 12. So 12 minus 5, 7 students are not waiting for the job. Same like that we will do for in high CGPA waiting for the job, NP dot sum of job 1 and N10 equal to length of IN2 of 0 minus N1. Now you can see we have calculated this value. Now we will calculate the Gini value. What is the Gini value of 0 equal to 1 minus N, because we have calculated this one, 1 minus N00 divided by length. What is the total number of students? IN1 of 0. We have calculated this one into, because we have to write the probability square into same thing minus the same thing we have to copy here. We have to write N01 and we have to write here N01. This is the Gini speed for low, and same like that we will calculate the Gini speed for 1. In this place we have to write 1, we are working for 2, here we have to write 1, we are working for 2, here we have to write N11, N11, here we have to write 2, and here again we have to write 2. Now you can see. So what we have done here for feature, first we are calculating, first we are applying the k-mean clustering, then we are finding how many students who belongs to the low group, how many students who belongs to the high group, For those students, we are calculating the job statistic, and then we are finding the number of students who is getting job, number of students not getting job. And then we are calculating the probability of the student who is getting job and probability of the student who is not getting job. And then we are calculating the Gini value. Final Gini value of this feature is nothing but equal to, now you can see, the final Gini value. Number of sample, number of student who belongs to the high category divided by total number of students. So alien length of IN1 of 0 divided by total number of student length of feature into G0 plus length of IN2 of 0 divided by length of features into G1. Now we are going to return. Now you can see. This is the code I have written. Now I'm going to check whether this code is working or not. If this code is working, then if you have any question, you will ask. And GF equal to, we are calculating Gini value. Gini value, we have written here Gini value. We are working for first feature, so data of all column 0. And the label basically contain the last column, so data of column -1. Now we have to execute and it will return the Gini value. So some place we are getting the reshape, we have to write where we are getting the error. So Gini value data of 0. Okay, so we have to write here reshape -1,1. Now we have to check whether it is working or not. Yeah, so now it is working. If we are going to check, this is the Gini value we are getting here. Now you can see. So for first feature, we are getting the Gini value 0.2798. We are getting the Gini value 0.2798. Now we are defining again one function that will calculate the Gini value for all features. So Gini value for all feature, where we have to pass the data, and for every feature it will calculate the Gini value for every feature. Okay. So how many features are there? 20 features. So we are writing here Gini value equal to np dot zeros 20, and for every feature we are getting for I in inch 0 to 20, and we are calculating GB of I equal to Gini value of data of I, comma this one, and finally we are going to return Gini value. So if you are going to check here, now I have written the code, and now we are going to check here. We have to check whether it is working or not. So Gini value equal to Gini value of data. Now you can see. So if you are going to check here, we have to check GB. Now you can see. So it is working fine. Some cases we are getting the not a number because that is not important. We are getting 0. But if you are going to check, it is working fine. 0.2798, 0.32, it is giving fine. Okay. Now we have to take those features which have the least number of Gini value, which have the least value of Gini value. Okay. So here what we have to do, if we are going to check here, what we are writing IN1 equal to np.arg sort of GP. Now we have to check what value it is returning. If we are going to check, GP value, so np dot sort, we are going to use here sort. So first 1 second, I have to check a little bit. So maybe I am using np.arg sort, we have to use. Yes, so it is working. So if you are going to check here, you can see. So basically it will give you the feature. It will give you the which feature more value. So if you are going to check 0, 1, 2, 3, fourth one. Fourth one has the lower value because we are getting 0.26. So basically it will give you the index one, which one has the lower value. And if you are going to write 0 to 5, we have to take only the top 5 features. If you are going to check here, now it will return you the value 40 something. Okay. So now again we are going to apply for all data set. So again you can see we are going to use the same formula, whatever the same code I am going to use here. Now you can see in this code again I am going to use the same code, but this time we have to call the Gini value. So now you can see, yeah, we are working for this one. First, now we have to calculate the GB, Gini value equal to Gini final. So we are calculating here in GB. Once we got the GB, now we are going to write here N1 equal to this one. There is no need to short it. Okay. So we are going to take only 0 to 5 because we are working on top 5 feature. And after that, now you can see we have got this value. After that, we have to add the last label. So just 1 second. Yeah. So now we'll get the idea. Okay. Now you can see what I'm doing in this code. If you are going to check here, we will write 51 into 2. What we are doing here, so first we are calling for the first college, and then after that we are calling the Gini all find feature. For all feature it will give you the Gini value, and once we got the Gini value, now we are going to find which top 5 features. So we are going to do the sorting. Okay, and the lower value of Gini split basically represent the better result. So we have taken the top 5 log 2 basically. After that we are going to merge our last one because the last one is the label. These are the features. The last one is label. So we are merging with the last feature, and then we are going to save our data. We are going to save our data with 51 into 2 because 0 to 51 1 to 51 basically contain the original feature. 52 to 102 contain the important feature using hypothesis testing, and 102 to 51 into 3, that is called 153, basically contain the important feature using Gini split. So now you can see if I'm going to execute here, it start working here and it will start generating the data. If you are going to check here, it will generate the more number of 5. Now you can see it is working and it is also generating the data. It is working, it is also generating the data. Okay. If you are going to check, it is working, it is also generating the data. Here you can see it will generating the data. If you are going to check here, it will generate the data. Now you can see if you are going to open the file, it will give you the only 5 features. If you are going to check first feature, second, third, fourth, and 5 feature, and the last one basically contain your last level. Now you can see this code is already. So what we have done till now, we have written the 3 codes. Till now we have written the first code. We are going to check whether the features are important or not. Second code, we are going to rank the feature, and the third code we have written for. Third code we are going to write for genetic algorithm because that is the important one. This session is mainly for genetic algorithm. Okay, so in the genetic algorithm, that is a one type of feature subset selection. Here our basic objective is to find the best combination of features. So here basically we are going to define our objective function. So what is our objective function? Is to minimize the number of features and maximize the accuracy of the model. That is our basic objective. In all the cases, this is our objective. What is objective? We have to find what is the minimum number of features. For that, we can get the better accuracy. So that's why here our objective is to two things. You can say like that, our multi-objective. We are working for multiple objectives. The first objective we are working for minimization of number of features, and second objective we are working for maximization of accuracy. Okay, now you can see the accuracy value we are getting between 0 to 1. We are taking 0 to 1. If we will take value 1, and if we are getting 95% accuracy, we will take the value 0.95. Now you can see number of features. Again, which one is best? Lower number of feature is best. Okay, we are getting lower. If I am going to define here term n minus number of selected feature divided by a. Now you can see again, try to understand what I am saying here. if you are going to write here, what I'm writing here, n minus number of selected feature divided by n. Now you can see what we have written here. If you are going, you will try to understand. If n means n, if number of feature is small, if we are taking one feature and the total number of feature is 20, 20 minus 1, that will become 19 divided by 20. If the number of selected feature 2, it will become 18 divided by 20. If the number of selected feature is 3, it will come 17 divided by 20. If we are taking all feature, it will come 0 divided by 20. If we are going to check, this term will come maximum when we have the least number of features. If you have one feature selected, it will come 19 divided by 20. If we have the two feature, it will selected, it will come 18 divided by 20. If we are going to increase the number of feature, the value of this equation will reduce. The value of equation will reduce, and it will always come between a 0 to 1. If you are going to check the inform, accuracy is also coming 0 to 1. Number of feature, how we are defining one formula, that will also come between a 0 to 1. If I am going to write this one plus accuracy, what is our main object? To maximize the value of this equation, because if we are getting higher accuracy and if we are getting this value maximum, when we will get the maximum? If you have the least number of feature. Now again we have to check, because now you can see accuracy is more important than number of feature, because in this case we are giving the equal weightage. But again you have to decide based on the domain, you have to decide how much weightage you are giving to the accuracy and how much weightage you are giving to the number of features. So as for example, here we are giving only 20% weightage to the number of features, because that is not that much important, but 80% we are giving to the accuracy. Again, try to understand. So what we have done here, we have defined one formula where we are working for both. We are working for number of selected feature and we are working for accuracy, and our main objective is to increase the value of accuracy and decrease the value of number of feature. But when we are decreasing the value of number of feature, this value become maximum. And after that we have defined one formula that will calculate the fitness value, that will calculate the importance of the feature based on two values. The first one, how much accuracy we are getting based on this feature, and what is the minimum number of accuracy. Okay, that for example, if you have the 4 feature and accuracy, you are getting 80%. And if you have the 3 feature and accuracy, you are getting 28%. Now in this case, we have to use this formula and we have to check in which case we are getting the maximum value. That one will consider as a important. So now you can see again, I'm going to write one formula that is called the fitness value. You can see define fitness, and that will take two values. One is called accuracy and second one is called the number of selected feature. And what value it will return? It will simply return, whatever the value. If you are going to write here, fi equal to what we are working for, 0.2 into total number of feature, we have the 20 minus number of selected feature divided by 20 plus 0.8 into accuracy. So basically it will return. So now you can see what we have done. We have simply calculated one fitness value. We have written one formula for fitness value, and that will take accuracy and number of selected feature, and it will return the fitness value. And again, we know the higher value of fitness function basically represent the best data or best set of features. Okay. Now, after that, if you are coming to the genetic algorithm, that is totally depend upon your observation. So here, basically, we are taking the chromosome. Initially, we are taking the n number of chromosome, or you can say like that. Initially, we are taking the n number of solution. Okay. Randomly we are taking the n number of solution, and for every solution we are going to calculate what is the equation. So as for example, here what we are representing, the each chromosome basically contain the value 0 or 1. So as for example, here you can see, if we are going to take here, we are taking one number, just simple, yes, this one. Yes. So now you can see if you are working for 50 chromosome, you can also take more. We have written 50. Now you can see here we are writing chromosome CHR. Okay, and sorry, CHR. We will take this one. We will take. We are not taking this one. Yeah, and number of chromosome in OC equal to we are taking 50. Now you can see what value it will return if you are going to check here. Okay, so what value it will return? CHR equal to we are writing 0 to 20 and we are writing here 50, comma. Okay. Now you can see if we are going to check every solution, only 0 or 1 each percent. If we are coming to the because we have generated 50 solution. Okay, randomly we have generated. We have no any idea which one is best. But if we are going to check the first solution 0, all, if we are going to write the first solution is saying like that. If we are going to consider feature is starting with 0, feature number 1, not 2, 3, 4, 5. Not 7, 8, 9. If we are going to consider only these features where we are getting value 1, what is the fitness value we will get? So basically what we have done here, randomly we are guessing the 50 solution and then we are going to find which solution has the better accuracy and how we can find based on the fitness value. But if we are going to check the fitness value, we are using one term called accuracy. And accuracy you can also only calculate if we are using some type of classification model. Because number of selected feature you can easily calculate if you are going to find the np.sum. np.sum, then easily you can calculate how many selected feature, how many features suggested by first solution, 9 features. You can easily calculate, but how we can calculate the accuracy, we need some type of classification model. So here we are going to use one model 1, where we have to pass our data. Okay, and we have to pass our chromosome CHR. And for that chromosome, means we have to pass our solution of chromosome 1. And for that chromosome, basically it will return what is the accuracy of the model. Okay. So here you can use any type of classification model, but now assume that we are using one classification model, and that is called the simple one we are going to use. That is called, you can use anyone. You can use either you can use support vector machine, or you can use the k nearest neighbor, or you can use the decision tree, or you can use any type of logistic regression, or you can use multinomial left-based classifier, or you can use a symbol learning, like you can also use the random forest classifier. So now assume that we are going to use here random forest classifier. You can use any classifier. You can use with KNN, you can use with anyone. So here we are using the random forest classifier. That is first case. Okay. So why we are using the random forest classifier? To calculate the accuracy. What is the accuracy of the model for this selected feature? Whatever the feature suggested by the chromosome 1, we are going to calculate what is the accuracy of the model. And how we are calculating the accuracy of the model? By using one technique called random forest classifier. You can use decision tree, you can use KNN, you can use anyone. Okay, but here we are using the random forest classifier. Now, or you can use simple one if you are going to check. Now we are working with the decision tree. That is simple. Don't be confused. Simple. Now we are going to take one model. Model equal to what we are taking here? Decision tree classifier. Now we have taken the model. You already know in the classification technique, you have to take some data for training and you have to take some data for testing. But before that, you have to normalize the. So I have also written the code. So due to the time constraints, I'm only directly going through this code. So what we are going to do before that, we are going to normalize the data, and here we are using the min-max scale. So we have to bring all the data in the same scale. So what we are doing like that, here we are using the min-max scaler, and basically this is used to normalize your data. Okay. So whatever our data is there, so we are writing data equal to data of all 0 to -1, because the last column we have to not normalize, that is our label, and we are calling here normalized data of all column 0 to -1. So what we have done here, first we have normalized our data. Now we are going to calculate what are the features selected by this chromosome. So IN1 equal to NP dot where CHR1 double equal to 1. These are the features selected by now we have to write data n equal to data of all column comma IN1 of 0. And what is our label? Label basically contain data of all column -1. Now we will see. So what we have done here, if you are going to check, first we have to normalize the data within the scale, and after that we are going to find what are the features suggested by the first solution. Okay, that we have calculated, and we have taken only those features. We have not taken all feature, and then we have calculated what are the labels basically contain the last column. Once we got this value, either you can use holdout or you can use cross validation. So here we are using the concept of cross validation, because you already know the importance of cross validation. So we are using the 5-fold cross validation. Also use 3-fold. You can also use 4-fold. If you have any question, let me know. Anyone, any question? Okay. So here
No,
we are
sir.
using,
Super no.
yeah. So you can use either 3-fold, you can use 4-fold, or you can use 5-fold, because nowadays we are not using the holdout method. We are using the cross validation approach. Okay. So here we are using the 3-fold. So basically it will divide the data into the 3 different groups. And at a time it will use the 2 group data for training and 1 group data for testing. And it will continue this process 3 times. Okay. So what we are doing like that, first we are finding what are the training and testing samples. So we are going to use here. See, it will basically split the data in, and it will give what are the training data and what is the testing data. We are writing TR data equal to data n of train index. Train index means it will give you, these are the data you will use for training. So train data, comma all, and same like that we have to use the testing data. TS data. TS data equal to test index. So they have given this data we can use for training, and this data we can use for testing. Now same like that we will write TR actual. What is the actual label? So we are writing label of train index, and same like that we can go for the TS actual. So either you will write this one, or you can write here data. Both are same. So either you will write data this one comma -1, or you will write here this one comma -1. In both the cases you will get the same value. So either you will write label or you will write data, you will get. So now what we have done here, sorry, code is not yet completed. So what we have done here, we have taken the training data, we have taken the testing data. Okay. And then we have also taken the what is the training actual data and what is the testing actual data. Okay. Now we are going to call this model. Whatever the model we have done here, now we are going to train the model. So we have to write the model dot fit. We are going to fit the model. So model dot fit TR data and TR. Okay. Once the model is fit, we are going to predict what is the model dot predicted for testing data, and we are going to store YP. Y predicted value equal to NP dot zeros. What are the shape of the data? So we are writing NP dot shape of data of 0, comma 2. What we have done here, if we are going to check here, what we have done here, like now we'll get the concept YP of text index, comma 0 equal to model dot predict of TS. If you are going to check what we have done here, if you are going to check here, what we have done here equal to yes. What we have done here, if you are going to check, first we are going to train the model. Model.fit means basically it is used to train the model. Model.fit. Once we have trained the model, we are going to predict what is the predicted value for the testing data. This is called the testing data. And we are going to save in the Y predicted column number 0. And the column number 1, we are saving our original data. So what is our original level and what is our predicted level? Once we got the original and predicted level, now we can calculate the accuracy. So once it is completed, now we'll calculate what is the accuracy of the model. What is the accuracy of the model? So again, we are going to use here term called accuracy. We have to calculate the accuracy of the models. We are using here one library called accuracy. And basically it will return what is the accuracy score. What is the accuracy score of, now you can see we have written the code here. So what is the accuracy score of, just 1 second, I have to check. Accuracy score, we have to pass first one, which value we will pass. So accuracy score of y1. Okay, the accuracy score of yp all column comma yp all column comma 1 and comma yp all column comma 0. Okay, now this is almost completed. What we have done, if we are going to check, we have used here decision tree classifier. Okay, that will not come under this one. Decision tree classifier will come in individual one, because we are getting the error. Okay, so this is your, it will come under the scalar library. Now you can see what we have done here, decision tree classifier, and we have used the min-max scalar to normalize the data. And here we are using the threefold cross validation, and for that we are calculating what is the accuracy of the model if this is suggested feature. So as for example, if I'm going to execute this one, now you can see if I'm going to use the first one, model 1 here we have taken. So if I'm going to use the model number 1, okay, model number 1, data 1 and chromosome number 0, comma. Now you can see what it is giving. If you are going to check again, we are getting the here some errors. So index equal to data of this one, we have to check somewhere we are doing the mistake. Okay, so first we have to check what is the size of the data. Okay, so this is basically the normalized data. So we have to take our original data. That's why these problems are coming. Okay, so now we have to take our original data, because this data basically represents the normalized, selected data. So now we have to read our first data. We are reading our data number 1, and then we have to calculate. You can see. Okay, so mismatch, it is giving the could not broadcast YP test index, comma test actual. So in the test actual, what we have taken here, so somewhere we are doing the mistake. This one become the test index. This is not the train index. Test index. Now you can see. Yeah. Now you can see if you are going to check what value, it is saying like the 71.2% of accuracy you will get if you are using your decision tree classifier and if you are using the feature suggested by the chromosome number 0. Now we'll calculate the fitness value for every chromosome. So now you can see what we have done, whatever the formula we have written here, now we are going to make only the single function that will calculate everything. So we are going to define here fitness value, and here we are going to calculate, this is called the accuracy. We are writing here AC equal to this one, ACC equal to, and whatever the formula we have written here, we are going to write the same formula here. Okay, so now you can see we have written 0.8 number of selected feature. You can simply calculate length of, or you can calculate NP dot sum of CHR1. So now you can see what we have done. Directly we have calculated this one, and it will return FP. Now you can see I have written one simple function. There is no need to write this one, because there is no need to write this fitness value. What we have written one simple function. Directly it will calculate the fitness value, and higher value of fitness value basically represents the best fit. So now again, if you are going to calculate the fitness, now you can see this is your fitness value. Now you can see it is giving 0.694. Same like that, if you are going to calculate for all feature, for all chromosome, what are the 50 chromosomes? So for I in range of 0 to 50, and if you are going to calculate, or directly you can write here fit value. If I fit value equal to, we are going to call this function called fitness value I for I in range of 0 to 50. If ITV, now you can see. Now, if you are going to check, now you can see this is the fitness value suggested by different chromosome. So first chromosome is suggesting 0.67, second one is suggesting 0.74, third one is suggesting 0.64, fourth one is suggesting 0.67. If you are going to suggest, everyone is suggesting some fitness value, okay, some fitness value. If you are going to write the basic case, now what we have right here, A equal to NP dot 0, and here we are writing, we are working for NOC, number of chromosome equal to 50, 3. Now you can see what we are writing for I in a range of 0 to 50. You will get some better idea here. For I in range of 0 to 50. Now we are going to calculate the fitness value, and here we have to pass fitness value, number of features suggested by this one, and accuracy. We are returning all three values. So now we are calling the fitness now we have to check what value we are getting here. You will see value. Now you can see. Now you can see the first one is saying with the 9 feature you will get the 72% of accuracy. Now the second one is saying I am giving you the better solution. With 8 feature you will get 76% of the accuracy. Now you can see someone will also give some better result. If you are going to check, it is giving the with 4 feature you will get 82% of the accuracy. If you are going to check here, now you can see. Now this is the advantage here. Now you can see out of 50 solution, you can see someone is suggesting with my solution is, if you are using these 12 feature, you will get 72% of accuracy. And he is saying like that, if you are using my feature, if you are using my solution with only 4 feature, you will get the 82% of the accuracy. Now will tell me which one is better. Definitely this is the better solution. How we can select? We have to find in which case we are getting the higher value of fitness function. So that is the first approach. If we are going to check, what we are going to do first, we are calculating the fitness function. After that, we are going for the crossover and mutation. Again, you can see. So in the crossover, what we are going to do, if we are going to check, now you can see crossover. What is the concept of crossover? So crossover concept means you already know. If we are doing the same task in the group, definitely we will get the better result. Okay, that is the concept of crossover. So in the crossover, what we are going to do, we are going to join the 2 different chromosomes. We are joining the 2 different chromosomes, and then we are taking one single chromosome. So how we are joining the 2 different chromosomes? As for example, now you can see. So 2 chromosome. If I am going to write, this is the 1, 0, 1, 1. This is the chromosome 1, 0, 1, 0, 1. Now you can see if we are working for 4 feature, and this is the solution given by a student 1, and this is the solution given by a student 2. What we are doing the crossover, we are taking the half of the solution of the first student and half of the solution of the second student, and we are going to define one new chromosome, which is called the crossover. Okay. So now we will write the code for crossover. Once we will write the crossover mutation, our code is completed. So in the crossover, what we are going to do? We are taking the 2 chromosome, and after that we are taking the first half of the first chromosome, and then we are taking the second half of the next chromosome. So now you can see we are going to define one function called crossover. Define crossover, where we have to only pass the chromosome CHR. After that, randomly we will take the 2 chromosome. It is not like that we will take in the different. Randomly we will take 2 chromosome, and then we will write this solution. If you are going to take randomly the first one, whatever we have written, this is the case that is used to take a random. Okay. So what we have to do? We are taking a NOC equal to 50. Okay, so what it will do like that, basically it will sample the data. So whatever the 0 to 50 is there, basically it will mix up. First it will make 1, 5, 3, 4, something like randomly, and at a time we are taking 2 values and we will go with that. So now we are working with how many chromosomes? We are working with 50 chromosomes. So what is the new chromosome? It will become new chromosome equal to np dot zeros, and it will only contain 25, because out of 50 if you are going to join, you will get 25 into 20. Okay. Now we'll go for everyone. So we are writing for I in a range of 0 to 25, and then we have to write NCHR, new chromosome of I comma 0 to 10. We are taking from original CHR of 2 into I. If we try to understand what I am written, 0 to 10, and then we have written NCHR of I comma 10 to 20 equal to CHR of 2 into I plus 1 comma 10 to 20. So try to understand what I have written. For I equal to 0, we are working 2 into 0, 0. 2 into I plus 1, 1. Means we are taking the first 2 chromosomes, and if we are going to check this one, you will get the idea what value it will return basically. If I am going to write here 30, and if I am writing here 30, if we are going to check what value it will give. If you are going to type here n, now you can see what value it will give. Basically it will sample the data 14, 1, 16, 7, 9. It will not give you the same sequence, but it will give you the same. If you are going to check, there is no any repetition is there, but basically it will sample it. Okay, so here we have done the same thing, and if you are going to check, at a time we have taken the 2 chromosomes, first one and second one, and first chromosome we have taken the first 10, and for second chromosome we have taken the last 10, because our chromosome size is this one. And after that what we are going to do, we are going to return NCHR. Now you can see. So what we have done here, if we are going to check here, what we have done here, we are going to return the NCHR. Okay. So NCHR we have written, that is called the crossover. We have to check whether we have written the right code or not. So NCHR equal to, we have to call the function this one, and then we have to check. Now you can see. So if you are going to check here, NCHR, this is called the NCHR. Now you can see. This is called the NCHR. Now after that, the second one is called the mutation. After crossover, the second one is mutation. So mutation means basically sometime what will happen like that, we are getting the good result, but if we are going to slightly modify the result, we will get the better one. Okay, so that is called the mutation. So sometime what will happen like that, if the students are coming with the solution, you are saying like the 99% your solution is right, only one place you have done some mistake. So done some mistake means some place instead of saying suggesting the feature, they have not suggested the feature. That is called the mutation. So mutation means only some place we have to change 1 to 0, and we have to change 0 to 1. That is called the mutation. So now we are going for mutation, and again we are going for the chromosome CHR chromosome. That is called the new chromosome. Only for the new chromosome, what we will do, only some place we have to change 0 to 1 and 1 to 0. So how many places? Only 2 places we are planning to change. So we are writing an equal to. Then we have to use the same thing, whatever the chrome we have used for this one. Okay. So now what we have done here, if we are going to check, an equal to np dot random, and here we have written 20, and for 25, because we are working for only 2 numbers. So what we have done right here means basically it will suggest for the first chromosome which position we have to make 1 to 0, and which position we have to make 0 to 1, but we have to only make for 2 different positions. So now you can see again we have to write for I in range of 0 to 25, and then we have to write here CHR of I comma an of I comma 0 is the first one, equal to 1 minus this one, and the same thing we have to write here. Okay, Why we have written 1 minus something? Because if it is a 0, so 1 minus 0 means become 1. If it is a 0, automatically this value become 1. If it is a 1, 1 minus 1, 0, so automatically this value become 0. And how many positions we are doing? Only 2 positions. So we have written this. After that, we are going to return. Now you can see we are going to return CHR. Now again we have to check whether this one is working or not. So now we have to write nchr equal to we are going for the mutation. We have to write mutation, and again we are going for the nchr. So mutation of nchr. Now you can see. So our code is almost completed. Now we have to write in the proper sequence, and this code is almost complete. Okay. So now you can see if you are going to check, this is the nchr. Only some places we have made 0 to 1, 1 to 0, 0 to 1, 1 to 0. If you are going to compare, you will get the idea. Now we are going to write our final GF program. So we are going to write define final GF. Okay. What we have to do? We have to pass only the data. Okay. Once we have passes the data, what is the first step? The first step, we have to take our chromosome. Okay, that is the first step. So we are taking this one. This is the first solution. Once we got the chromosome, first we are going to take what is our best chromosome, means what is the best fitness value. Initially we will assume like that our best fitness value. We are not getting any best fitness value. That's why we have written B fit equal to 0. Best fitness value equal to 0. Okay. And our objective is to get the better result. Now here you can go with the certain iteration. So we are going with the count equal to, we will go with the count equal to 0. And we are going to check while count is smaller than 30 iteration, 30 generation. You can go with the more generation. If you are going with the more generation, it will take more time, but it will give you the better result. But due to time constant, I'm going up to 30 generation. That's why we have written count equal to 30. Now, what is the first step? First, we'll calculate what is the fitness value. Okay, so we are going to call the same thing, whatever we have written here. So we have called the same function to calculate the fitness value. Okay, so for every chromosome, we are going to calculate the fitness value. Once we got the fitness value, now we are going to find in which case we got the best fitness value. Okay, so we are writing in1 equal to np.arg max of FITV of all column 0. Because if you have remember, the first column basically contain the fitness value, second column basically contain the number of selected feature, and third column basically contain the accuracy. But our objective is to find the best fitness value. Okay, what is the value of best fitness? Current best fitness value equal to, we have to call the same thing. Instead of that, we have to write maximum. Now we get both. IL1 basically represent which chromosome has the best fitness value, and CFIT basically represent what is the best fitness value. Now we have to check if CFIT is greater than BFIT, best fitness value, then we have to write BFIT equal to CFIT, and then we have to take best chromosome equal to CHR of IN1, all column. Okay. If you are going to check what we have done here, basically what we have done here, we have calculated whether this current fitness value is greater than best fitness value or not. If it is coming true, then we have to replace our best fitness value equal to current fitness value and best chromosome equal to whatever the chromosome. And then we are also going to print here. We are going to print here what is the BFIT, best fitness value we are getting here. Okay. After that, we are going for NCHR, new chromosome equal to crossover. What is the crossover? We have done this one. We are going with the crossover. We have to write 50 here. And then we are going for the mutation. Okay. We are going for the mutation. Okay. Mutation. So we are writing here. This is called mutation. So mutation equal to again NCHR. CHR equal to NCHR. Okay. Once the mutation is done, we are going to write CHR 0 to 25, all equal to NCHR. NCHR. What we have done, whatever the new set of chromosome we will get, we have replaced with the first 25 chromosome. And after that, the next 25, whatever the next 25 we are getting here, 25 to 50, we have generated some new solution. So again, we have to take this one. 5, and then we have taken count equal to plus 1. Now you can see what we have done for the mutation and crossover. You will get only 25 chromosome, but originally we have the 50 chromosome. So what we have taken, the 25 chromosome we have taken based on the mutation and crossover, and 25 we have generated the regeneration. We have taken the new chromosome. Now this is the final code. I'm going to check whether it is working or not. If it start working, means our code is complete. Now you can see, we will check whether it is working or not. So some place we are getting the problem ARG, AGR not ARG, ARG max. Okay. Now we have to check. Yeah, now you can see this code start working here. If we are going to check, first we got 0.7 as a best solution. After certain iteration, we get the fitness value 0.77. After certain iteration, we get the fitness value 0.7764. We got 0.79, 0.81. If we are going to check slightly, we are increasing the fitness value. Means if we are going to increase the number of iteration, definitely we'll get the better result. But time constant, I'm going with the limited one. And finally, we will return. Finally, once you have completed, we are going to return the best chromosome. BCA. That is called the best. Now you can see this code is come. Here I have taken the same, whatever the code we have written for the Guinea split. I'm going to take the same code here, and we have to write here. So now you can see I'm going to write here, and then we have to write here. The first one we have to write here, Guinea, not Guinea, GA final GA, and we have to pass our data. So we have to write here final GA. It will give you the best chromosome BACHR. Then we have to find IN1 equal to NP dot, where BCHR double equal to 1. So what are the solutions suggested by this one? And then we have to write here IN1 of 0. And here you can also write here print length of IN1 of 0. So basically it will give you the idea how many features selected by this chromosome. Okay. So we are writing here. You can also write here. There is no confusion. And data 1 and data 1. Data for data, comma, str of I, comma, str of. Okay, so IN1 of this. So if you are going to check this one, we have done. Yeah. So now you can see what we have done here. First, we have calculated what is the best chromosome and what are the features suggested by this best chromosome. Then we have taken only those data in. Then we are going to concatenate with the last one, and we are going to write 1, 2, 3, and we are going to save the file. So now you can see if I'm going to check whether it is working or not. It's a start working. Now you can see it start working here. And if we are going to check for data 0, the only 8 features are selected. For data 1, again you can see we are not getting the best one. Data 1, this number of features, but if you are going to check slightly, it is going to be modified. Okay, and here we have generated all the data. So if you are going to check what number of data we have generated, the first 0 to 51 is the original data. The next one we have generated 51 to 102, is called the significant data. Then we got 51 to 102 to 153, that is called the Guinea split. And after that we have taken the genetic algorithm, that is called the 153 to 204. It will come 153 to 204. Now finally we are going to compare which one is coming the best result. Okay, which one will give you the best result. Okay, so now we are going to use the different type of classification. So at least we will use the 10 classification, that we can make the conclusion which one is giving the better result. Okay, so now you can see again we are going to write the code for this. Code is running. We are writing model number 1, where we will pass the training data, TR actual, and TS data. You can see how simple this code is. Sorry. Once we got this model, now we are going to write model equal to. First, we are going to use the simple one, Bernoulli-Nebel classifier. Dot fit here data comma here actual. After that, we are going to return model dot predict yes data. Now you can see first model is complete. What we have done here, we have taken Bernoulli-Nebel classifier. We are going to fit the data, and after that, we are going to predict. Simply, we have to do the copy paste here. Now you can see. Now the second one, we are going for the model 2. We have to only copy paste here multinomial Lebesgue classifier. So here we have to write multinomial Lebesgue classifier. And multinomial Lebesgue classifier. Next one, this classifier we have to write here only Gaussian Lebesgue classifier. That one become your model number 3. Model number 4, we are going to use decision tree classifier. So we have to write here only decision tree classifier. And we'll go for the decision. After that, logistic regression classifier, we have to write here logistic regression classifier. And we after decision tree, we have to write logistic regression classifier. That is called the model number 5. Okay. Same for model number 6. We are going to use the k nearest neighbor classifier. That is called the model number 6. So now we are writing here model number 6. We are going to use the k nearest neighbor classifier. Neighbor classifier. Okay. Same like that, if you want to use the what we can say random forest classifier, so directly we can use this term random forest. Okay, so model in place of this one logistic regression, we have written k nearest neighbor classifier, that is called random forest classifier. That is called the model number 7. Now after that, we are going to write here. If you want to write, now I'm going to write here support vector classifier. So we are going to check here 3 input. Now we are taking after random forest, we have taken support vector classifier. Polynomial. This is called the model number 7, model number 8, model number 9, and the last one will go with the model number 10. Model number 10, and here we will go with the RBF. Yeah. So now you can see we have written the 10 different model. If you are going to check the first model, we are using the Bernoulli, second model multinomial, third one Gaussian, fourth one decision tree, fifth one logistic regression, sixth one KNN, seventh one random forest classifier, eighth one we are using the support vector classifier with the different kernels. Okay. Once this code is ready, now I have written the code. Once the GA will complete, because currently the GA is running here. If you are going to check, currently the GA is running for 39 features. Once it is completed, now again we will call for the all data set. Okay. So again we are going to use the what number of fold. Either you will use the 5-fold or you will use the 3-fold. That will totally depend upon you. So again I am going to use the same code, whatever the code we have used here. So we are going to use the 3-fold or 5-fold. Whatever the fold you are going to use, we'll use it. So we are going to use the 5-fold. We are working for I in range for I in a range 0 to 51 into 4, because we are working for 4 different set of data. First one is your original data, second one is called the significant feature, third one is called the Gini split, fourth one is called the genetic algorithm. So first we are going to read the data. So whatever the code we have written here, we have always tried to reuse the code. So I'm going to reuse the code here. So whatever the code I have written, I'm going to use the same code here. So once I got the data, okay, Now after that, what we are going to do? After that, we are going to use the train and test. But before that, we have to normalize the data. So we are writing the data. Whatever the code we have written previously, we are going to use the same code here. So normalized means we are going to use there, and this one is called normalized data. So I'm going to copy paste here so that it will become easy for you. Normalized data. Then we'll use the train and test. Train and test. Normalized data. Then we are going to use train and test. So now you can see, so it is already completed. If you are going to check, our code is already completed. So now it will start working for our final model, our final comparison. Okay, so first one, we are going for the normalization. Once the data is normalized, we are going for the model development. So we are going to find what is our training data and what is our testing data. So now you can see, once we got the training and testing data, we have to save our y predicted value. So we are writing yp equal to np dot zeros. Okay, then we have to find the site np dot save of data of 0, comma how many features the model we are working, 10 models. So we have to write here 11 because 1 is your original data, 10 is your this one. Now we are going to write here y predicted of all column comma 0 equal to, we are calling comma tr actual comma ts data. For all the case, we have done the same thing: training data, testing data, model number 10. That is your first model. Now the same thing we will call for the ts data. Now we have to check if there any error is there. Ts data. Okay. So what error is coming here? M is not defined. Where we are using M. Y model 1. Okay. So data, we have to write data. Okay. Okay, we have to check what the error is coming here. So data we have already done, data of normalized we have done, y shape equal to this one, kf split, training data, testing data, we have already done it. Okay. Now we'll go for model number 1, model number 2, model number 3, model number 4, 5, 6, 7, same like that. Model number 8, model 7, model 8, model 9, model 10. So we are writing 7, 8, 9, and then we are writing here 10. Here we are going to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last one is your YP. The last one is your YP of 10 equal to TS ACT, TS actual, and this is only work for test index. So we have to write here test index, test index. What we have done here, we have called the 10 different types of model, and for every model we have calculated what is the predicted value, and the last column basically we have written our actual value. Once this code is completed, now we have to calculate. After that, we have to calculate what is the accuracy of the model. So again, we are going to take another variable that is called the accuracy value, and accuracy value np dot zeros. We are working for how many models? 51 into 4 data set, and we are working for 10 models. So we have to calculate for every model, we will calculate the accuracy value. So now we are going to write here for j in a range of 0 to 10. Okay, 0 to 10, and then we are writing ACV of I comma j equal to accuracy score. So whatever the accuracy score, you can also calculate the F measure, you can also calculate the precision, recall, everything will calculate. But due to the time constant, I am only going with the accuracy score. But in place of accuracy score, if you are going to write F1 score, it will work for F1 score. If you are writing precision, it will work for precision. So here we have written the accuracy score. Here we have to write the accuracy score of YP. yp all column comma -1, because that is our original data. Okay, that is our original data, original level, and yp of all column comma j. So now this is already completed. The code is already completed. We have to also write here. We have to also write here print of I, so that we will get the which data set it is working. So now you can see this code is almost completed. We are going to execute it. If any problem will come, we have to tackle it. So the problem is coming, index 0 to 9 out of bound. So train index, test index. Okay, so we have to write here data. This is not the data in data. This is also data. And we have to now you can see this will start working here. Okay, once it will completed, now our objective is to compare which one is giving the better result. Okay, so here we have to use the box plot diagram. I have also written a little bit the code, and we have to find which one is giving the better result. Okay, so now we have to take so first one we are working with the ACB. This is called the accuracy value ACB, and the labels we are going to write because we have to write in the column wise. So the first one we are using Bernoulli naive-Bayes classifier. Second one we are using the GNB Gaussian naive-Bayes classifier. Third one we are using the second one is multinomial naive-Bayes classifier. Third one is Gaussian naive-Bayes classifier. Fourth one is called decision tree. Fifth one is your logistic regression, LOGR, logistic regression. Sixth one is your KNN. Seventh one is your random forest. Eighth one is your support vector classifier with linear kernel. Ninth one is your support vector classifier with monomial kernel, and 10th one is your support vector classifier with RBF kernel. So if you are going to write this code, automatically it will print, automatically it will draw the box plot diagram, and based on that you can easily conclude that which one is giving the better result, which types of model is giving the better. Same we have to compare for our feature selection techniques. So which types of feature selection technique is giving the better result. But how will work when we are going to put the data in the column measure. So now we are writing accuracy of feature selection equal to np.0. For each feature selection, how many times we are using? 51 into 10 times, and we are using the 4 set of features. Why we are writing 51 into 10? Because we are working for 51 project. We are using the 10 different classifiers. So we are writing 51 into 10, and then we are writing 4 here. Now you can see how we are writing for I in range, a range of 0 to 4, because we are working for 4 feature. For J in a range of 0 to 51, we are working for 51 data set. ACBF of, try to understand what I am writing here, 10 into J2, 10 into J plus 1, 10 into J plus 1, comma I, equal to ACB of 51 into I plus J comma all column. Try to understand what I have done here. If you are going to check here, when the value of I equal to 0, basically you are working for all feature. And here, whatever the 51 into 10, the value accuracy value will come, we are going to put in the single column. When the value of I equal to 1, we are working for significant feature. We are putting in the second column. When the value of I equal to 2, we are working for Gini state. When the value of I equal to 3, we are working for genetic algorithm. Again, if it is completed, again we'll go with the box plot diagram. Box plot diagram, we have to print the box plot diagram. This time we have to write this one, and this one we have to write all feature. Here we are working for SIGF significant feature. Here we are working for Gini. The last one we are working for genetic algorithm. Due to time limit, I am going a little bit faster. So genetic algorithm. If you want to save, you can save it. File name equal to, I'm going to shape this file. File name equal to str of file location plus technique, and here we have to write file location plus if feature selection technique. Now you can see it's working. We will wait. 182 is already completed, so we will get 204, 186, 188, 189. So maybe it will take 1 or 2 minutes. It will not take more than that. So now you can see it is almost completed. Yes. So it is almost completed. Now you can see here. If you are going through this one, we have generated the two different diagrams here. Now we will go with the diagram and then you will take the conclusion. You will find what types of conclusion you are going to make here. Okay, so where is that diagram? Okay, file location plus. Okay, so basically we have to write here. Yeah. So now you can see if you are going through the technique wise, if you are going to check here, we are getting this much of accuracy. If you are going to, it is not opening, but if you are going to take here something called ACV, accuracy value. Now you can see this is the accuracy value we are getting here. Okay, you can see this is the accuracy value we are getting here. Either you have to write here in 100, and here you have to also write into 100. Now you can see, yeah. So if I'm going to compile the code here, now you can see we are getting this types of accuracy value. It is not looking great, but if you will change here, we are getting this types of accuracy value. Okay, so here we have calculated. Now we'll check somewhere, maybe we are not doing any mistake. J in range of 0 to 10, we are getting the accuracy values, and this is the accuracy value we are getting here. If we are going to check, this is the accuracy value we are getting here. Okay, so here we are getting 0.992, 0.992, something like that. This is the final accuracy value we are getting by using the different technique, and you can represent by using the box plot diagram. Okay, after that we are also trying to find here. Now you can see if you are going to check this one, we are getting np dot mean, and whatever the value we are getting acbf comma axis, x is equal to 0. Now we have to check what value it is printing. ACBF. Now you can see. So if you are going to check here, we are getting 98% on an average. We are getting 98% of accuracy if we are using all feature. If we are using significant feature, we are getting 99% of accuracy. If we are using the next one, Guinea split, we are getting 99% average accuracy, and here we are also getting 98% of accuracy. Somewhere we are doing the mistake, or we have done the right one. STR of I plus 1, normalized data. We are reading the data here. np.save, we have done the by predicted, and we are returning the by predicted model.predict data on the TS data. Okay, so that we have done rightly. Y predicted of testing data equal to TS actual, TS data. Okay, fine. Test index, yeah, we have done rightly. So we are getting this much of accuracy if we are going to check. If we are going to use the genetic algorithm with the least number of features, we are also getting the nearly equal to the same accuracy of the all feature. Now you can see in all features we are also getting 98% of accuracy. But when you are using the genetic algorithm with the least number of features, we are also getting this one. Here one important point, if you are going to check here, I'm writing one important point. If you are going to check here, np.0 4, 4. Now you can see this is very important here for I in range of 0 to 4, and for j in range of 0 to 4. Now you can see we'll get very important point here. P value equal to rank sums of ACBF all column comma I comma ACBF all column comma j, and P of I comma j equal to p value dot p value. Now you can see This is very important conclusion. Now you can see, if you are going to check here, now you can see this is the all feature we have taken. Also, if there any significance difference between the models developed using the all feature with the models developed using the GA, what we are getting the value less than equal to 0.05. Means what we can say like that, if we are using the genetic algorithm, you will get the significantly better result as compared to the all feature. You will get significantly better result as compared to the all feature. Now you can see here we are getting 0.9824 and here we are getting 0.9895. So with the less number of features, we are getting the better result as compared to the all features. So this is the advantage of using genetic algorithm. Okay. And here I have written the whole code. Maybe it will change if we are going to use the different type of classification technique. Maybe the conclusion will change if we are using the different types of classification. So here you can see for the preference value we have used here model.predict, and if you are going to check the model we have used here and decision tree classifier. So if you are using the different model, maybe the performance value will change. Okay, maybe we will get the different set of feature, but till now we are getting this one. So up to here, if you have any question, then let me know. Anyone, any question? If you want this code, just please share your ID in the chat box. I'm going to share this code with you. You can go through this code. If you want to modify, you can modify. So if anyone need this code, please share your ID in the chat box. I'm going to share the whole code. You will get the whole code you can use for your research purpose. You can use anywhere. Clear? So if you have any question, then let me know. So,
Hello.
yeah, hello. Tell me.
Sir, thank you very much for your excellent lecture. Actually, right now I'm not having any question, but the fact is that some question may arise in the future. So my humble request to you is that would you please be kind to allow me to communicate with you through email, and it will be
Yeah,
very
sure,
kind
sure.
and great. Thank you very much, sir. And it will be very
Thank you.
kind and great of you if you please be kind to share your WhatsApp number with us. So that we can
Okay,
be
so my
in touch.
WhatsApp number is 8260612877.
So would you please be kind to write it down in the chat box? Okay.
Yeah,
Thank you
I
very
have
much, sir.
written.
Thank you very much, sir. Thank you very much.
Thank you. Anyone, any question? If you have any question, then let me know. So when you will go through this code, then you will get the idea how we are writing this code. If you go the simplest way we have written the code, if you are going to check, most of the cases we have used the simple one. If you are going to check here.
For your
If you
official
have any
email address,
question,
please.
yeah, my email address is lovekumar@nitkkr.ac.in.
Okay. Thank you very much, sir.
Thank you. Anyone, any question? If you have any question, then let me know. Okay, Susmita CMR IT. Oh, okay. So if you have no any question, then maybe I'm going to close the session.